Hey, hey. We are going to start. Wait, the music is a bit loud actually. Let me fix this. 1, 2, 1, 2. Yeah, okay, should be fine, right? 1, 2, 1, 2, 1, 2. Testo. 1, 2, 3. Boo. Okay, let's listen to this really quick. I should have continued. 1, 2, 1, 2. Okay. Yeah, okay, should be fine, right? 1, 2, 1, 2, 1, 2. Testo. 1, 2, 3. Boo. Yeah, okay, this is pretty good. This is pretty neat. Great. So let me just set up a few things and we'll get started. On the program, there's collisions. We have to finish those. And yeah, I guess that's it. Okay. Okay. Yeah, let me fix this. Wait, there's no music. Wait, I just removed it. Okay. Oh, hey, how are you? Okay, here we go. Wait, let me get everything ready. Hey, you have problem, how are you? Hello. I'm okay, great. What are you up to? Wait. Wait a second. Yeah, I'm up to okay, if you say so. I mean, my code is the same actually. My code is up to the same thing, so I can't really, say anything to you. I had a problem. Can you help me find it? Because it shouldn't be too hard. It's about Godot. It's about casting a type to another type, but it is inaccessible. I can't cast my collision simulation group to a node, but at the same time, this is a node 3D, and I have the header. Do you have any idea what the problem is? It's like, it's really a very simple, error, but for some reason it's just not, working. And it's apparently with the add child. Wait, what? wait, what? Jog solution. Offhand, no. Jog solution reinterpret cast. I'm sure it's going to work. Wait, can I actually? Can I actually just do this and have node? Wait, what is that? Yeah, it's my normal thing. So yeah, this is not working. Conversion to inaccessible base class, not really. What is that? Why? Inaccessible base class. But I have the base class there. Right? Oh, actually I don't. Wait. That's not... Okay, I have it like there. Pretty close. The cast to cast everything to everything. It's been a long ass time since I've done CPP though. Yeah, I know. I know what reinterpret cast is, you're right. But is something in there constant? That's a good question. I think it was saying... Yeah, it was saying that actually. So, I mean, this is not constant though. I'm just creating the object. This is basically a new, right? So I mean, there's nothing constant here. And I'm trying to assign it to, well, right now a node, which is like the parent of the parent. But like I can try to assign it to a node 3D, which is just the parent, and it's not working. So I was thinking maybe it's because I'm not including this, but I have the include there. I actually have the include, right? So it should know the parent. It should know about the parent. It should know about node 3D and node. And it doesn't. So that's why it's so weird. Right? Oh! Junk space collider. Wait. It's a node. Requires param node. Yeah, but this is not working either though. Inaccessible. Oh, it's a private. It's inaccessible because by default it's a private inheritance in C++. That was so stupid, okay. Okay. You actually helped me a lot. Just by, talking to you about it. That was actually pretty, thank you a lot for that. I completely forgot about that, me too. Me too. Actually, last night I was trying to fix it and I just gave up. And yeah, just thanks to you, like you got here, you got in the chat, and I just talked to you and I don't know, it just clicked, right? Like, I wanted to show you like about the inheritance because I know it's inheriting, but I have to show it, right? And yeah, by showing it, kind of, I don't know, I noticed. So thank you for that. Do you know what the game is about? I mean, I guess you can you can see that in the title, but yeah, I don't know when was the last time you joined the stream. Actually, I don't know how long it's been. It's been a while, yeah. Was the last time about the card game? Right. Chunk collider instance. Probably. Oh, Ravili! Hello! How are you? How are you? I knew it. I should have added Minecraft in the title. So everyone just joins the stream. MG, hi, hello! We'll be lurking, but hi! Do you want to see something incredible before that? Thanks a lot. Well, no, thanks. Well, both. Here we go. Please work. Okay, I'm gonna show you something incredible. So in the title it's saying Minecraft in Godot, but it's actually not just Minecraft. I'm actually trying to do something crazy, and that's why I have all of those classes about collisions and space and stuff, okay? And the reason for that is, yeah, let's wait just a little bit that it compiles. And yeah, I'm not sure the collisions are going to work right away though, or like entirely, but I can at least show you how it looks like. It looks like shit for now, but it looks also kind of crazy. Okay, here we go. Okay, it compiles now. Thanks, B. It's opening. Okay, I have this. So, update colliders. So I have a few problems. And... Oh. Okay, let's try something. collision group. So this is going to be collider.create, or like something spawn new simulation group. I guess it's a simulation group. And then I'm going to put that there. So this one is collision simulation group. Okay, okay. Are you ready? Here we go. Please don't crash. I don't know about the collisions really. Oh, observer. On a base object of type invalid assignment. Oh, I have multiple observer. Right. I might remove this for now. And I might do... Oops. Oh, I don't have observers there. You know what? Let's just play it. It's gonna crash, isn't it? Oh no, it's not. Okay, okay, here, okay. Perfect. I do have a few errors, it seems like, but this is fine. This is just collisions. I'm just gonna comment this. Okay, are you ready? Are you ready? B, ravioli. Well, if ravioli is lucky, maybe not, but are you ready, B? So, ta-da! I was born ready. Great. So yeah, I have basically some donuts. I have a ring. I have a torus. A halo. You can call it in a lot of ways, indeed. And it's made out of voxels. So as you can see, I can just destroy those. Right? It's like Minecraft. For now, there's like no terrain generation though, but yeah, I can add this. Well, I can add it pretty easily actually. So it's not a big deal. I can dig down, but the thing is, it's a torus, right? It's a ring. So when you dig down, there's a problem. When you dig down, it's doing, you know, it's becoming a rectangle. And it sucks, right? It just sucks, right? So yeah, that's a big problem. So what I did was I just didn't do that. What I did was instead... Oh, because, wait, let me show you maybe a bit better. Because when you have a donut and you look inside, does Guilty Spark get mad about you damaging his halo too? That's very cool. Look at this. You know, like, if you visualize it from the inside, you can see that every cube actually gets towards the center, right? Because it's normal, right? It's a donut. Because, like, every cube is on top of another cube, and it's, like, making a circle, right? So it's, like, getting, like, really small, and you have rectangles, and it sucks, right? So I just added this. And let me show you a bit more. I'm gonna actually use my other camera. So not this one. Oh, I can actually switch. I made a button for that. I don't remember the button though. It's not... Is it H? No. Y? 1. It's 1. So let's go up. So the thing is, now I can actually walk on the on the terrace, on the donut. So this is like one thing. I can actually walk there, right? And the other thing is, I can also dig down. And it actually stays a cube. It's actually a cube now. No more rectangles. But if you go out, you can see that in the distance it becomes a rectangle. And it's still like, well, it's still a torus, right? It's still a ring. If I go around, it's still a ring, right? But it's just cubes when you're close. And you know, you can like do your normal Minecraft thing in there, right? You can like dig blocks and stuff. That's crazy, right? But you're inside a ring. And Can you dig through to the other side? You can't actually, because if you continue down, you have this limit. You can go through, and you can... What can you do? Ah, wait a second. Where am I? Wait, it's like the opposite. So down. I can go there. But... Okay, here we go. But yeah. Wah. Wah. Ah! Wait, let me go. So this is done. I don't know what is up and what is down. Wait, my camera is like completely broken. Okay, here it is. Wait, no, it's not. Shift makes me go up. No, because, yeah, basically, you can't go through because then, you know, there's like a problem with the gravity. There's a problem with, I guess, the geometry. There's a problem with so many things, right? And, like, technically, it's not as if it was cubes. Like, if you actually check inside now, let me go maybe there. If you check, it's still like converging towards the center, kind of. So, you know, like there's a single line in the center of the torus. So if you dig down, technically all the cubes end up at the same place, right? So it's like kind of an entropy point. Because it's not flat, right? Like it looks flat, but it's actually still not flat. And the thing is, to make it look like it's flat, there's actually some kind of transformation that goes on the entire time, as you can see. And like when you get close, it becomes cubes. But when you're far away, it actually turns back into going towards the center. So that's why. It's like crazy, right? When you try to visualize it. And, right, it's like normal torus almost there. And yeah, that means you can, you know, dig there. You can dig there. And when you try to, for example, go up, what happens? Well, you actually rotated along the torus. Right? Like if you check the two holes, it's not flat. It's not flat. It's actually rotated. So what that means also is, let's go back there. If you continue digging down this road, this way, well, down, it's not down, it's, you know, on the side. If you continue digging this way, just a bit. I guess it's a bit long, but it's fine. It's gonna be fine at some point. It's basically, well, I mean, I guess you already know what's going to happen. But yeah, I just go back to my previous position. Because it's a circle. It looks like I'm always going in a straight line. But it's actually a circle. So I just come back here. That's crazy, isn't it? That's actually the first time I'm doing that, like digging from one side to, well, to the same side, but to the same place. But yeah, and it's the same with like the other way. It's just going to take a lot longer, right? Like if I dig in that direction, like there, I can actually go around the whole way, but have it still look like I'm going straight. Like right now, I'm just going straight, right? Like, let's continue a bit more. Let's click faster. Sorry if it looks like a bit bad. But you know, I'm like straight, right? I'm going straight. But if I dig up and look back, where even was it? So I have a few holes here, but that's not what I was looking for. I'm just gonna make a lot of holes to see it like very quickly. But I should have something along this way. Yeah, okay, this is a hole. Right, this is the hole I come from. There. And if you look at it, can you see the two? Like basically kind of like there and there. So yeah, that's kind of crazy. And I was actually thinking about making even more crazy things. There's something called, well, this is basically called a flat torus. It's a flat torus in 3D. But there's also something called non-Euclidean geometry. And I actually thought that this was non-Euclidean geometry, but this isn't, because it's Euclidean locally. But yeah, non-Euclidean geometry, for example, you have hyperbolic cubes. Like this. And let me show you something easy to understand. Yeah, like, well, maybe not like this. Squares. Let me put squares because it's like in 2D. But basically, let's say you have, okay. So this is, let's say that this square, which isn't really a square, but let's say it's a square. This is a cube, okay? This cube is connected to 4 other cubes, right? But the thing is, you know, this one is connected to 4 other cubes too, right? Etc. But this vertex is connected to 5 cubes. That's kind of one of the things I wanted to make. But it's, you know, it's gonna be a bit complicated, and I think I'm gonna work on the visuals first. For now, I'm just making like the overall system, the overall like architecture, and making sure it's flexible enough for that, but not yet. I actually have a video about it. What is... This one looks meh. This one is made by someone I really like a lot, who made Hyperrug. I mean, I guess we can look at Hyperrug. But then there's... Anyways. Doga. So... Do we have... cubes or... We have octagons. So, you know, how, as you move, you can move from one tile to another. But the shortest distance is kind of weird. How to say it? Like, if you make a triangle, the sum of the angles is not 180. Wait. Yeah, 180. So that's why the world is, you know, moving, let's say, when you move yourself. It's not really moving, actually. It's just the projection. It's just how you visualize the space. But yeah, and you have like a lot of different worlds in Hyperrug. That was like kind of some kind of inspiration from me that I discovered a few years ago. And yeah, like for example, like this triangle is connected to 1 triangle, 2 and 3 triangles, right? And same for this one and same for this one, 3 triangles every time. But this point is connected to, well, so it's a triangle, right? So it should be like, this one should be equilateral. So like 60 degrees, 60 degrees, 60 degrees, right? But if you look at this point, and you know, you try to make a circle around, like a circle is 360 degrees, right? But if you sum all of those, actually you get, well, yeah, okay. If you sum all of those, you have 1, 2, 3, 4, 5, 6, 7 triangles. And 7 times 60 is not 360, right? It's like 430, I think. So, you know, the angles are kind of wrong, you could say. And yeah, that makes it like a bit more interesting, you could say. But yeah. And you have... Wait, let me close this. You also have... This one that is great. This video that is cool for 3D. So let's have it there. Here we go. So yeah, basically you're inside a cube, okay? And you can move to other cubes, right? But when you go to another cube... Wait, please move. Okay, he's moving a bit. And yeah, when you move to a cube, please move to a cube. Go! So yeah, he's moving forward, right? You have like this connection. But as you can see, this vertex has like 5 different cubes around instead of 4. So even if you try to walk like in a square, it's actually... You're actually not going to back to your... to where you started. So I really want something like that. With crazy geometries. But it's like a bit complicated. It's like a challenge with voxel games. So, because there's like generation too, right? So, I mean, yeah, that's basically it. Yeah, like if you have any questions, feel free to, you know, ask and stuff. But for now, I have a few problems. Get collider. Invalid getter. Wait, what? Invalid getter. Where? Class DB. Gets collider. For property chunk space. So chunk. Okay, let's go there. We have chunk space. And we have this. Can I just... Interesting. Set and get. It returns a node. I mean, it should be good. Gets... Oh, it's get collider. Never mind. Get collider. It returns an object. Okay. What if I go there? Get visual... Wait, what? Wait, what's the deal? They're like... inverted. Okay. Okay, should be good now. Should be just a bit better. Invalid setter for set space. Wait, chunk shape space. Chunk space. Chunk space. Okay. So chunk shape, set space. Oop. Set space. Yeah, I don't have that. Well, it's actually just space. Well, it says space. So let's go space. We have this, we have get space, and we have set space. Well, we should. But it's actually a shape now. Wait. Now we have the shape. And we don't have anything for the space, though. Do we? Set space collider. I guess it's gonna be space... collider. And it's set space collider and... Oh, right, I need to... Wait, what do I need to do? I need to bind to the right one. Okay. Okay, so here we go. We have another problem fixed. This is just unused, so this is fine. And we had... The problem I had was I have my simulation group, but I can't access my observers. So the observers are basically the entities that are going to generate collisions around. So I'm going to go in my simulation group. And I have my array observers. So now let's just go in my, not there, space. Because I have something very similar. I have this. I should be able to set it to, right? Yeah. So something like this. That should be... Yeah, it's not working actually. I don't know why. Maybe you can help me with that too. Variant to space observer. So is it that I did the same mistake? No, okay, it's public, right? It's public now. Too bad. Set. I really don't know what the problem is. Because that's the only place it's not really working. Well, there's actually only two places I'm using this. But yeah. So it's working there. For chunk space. With set modifiers, and I have modifiers. Do I have something unique to chunk space or something? No. Okay. So I have the collider. I have the... Is it just not matching? I mean, it should just be an array, yeah. And yeah, this is like the conversion that's not working for some reason. So this cannot convert. So this is trying to get converted to node. Or like object, I guess. And no suitable conversion from variant to space observer star. Let me check with Godot. Godot, no conversion from variant. Godot returns a generic dynamically typed variant container. Strongly typed. Yeah, that's not really true though. Yeah, I got this last time too. It's not really true. Because it works in the other case. It works for this. So like I have modifiers. Oh, but it's a ref class though. Oh! Wait a second. I might get it. Assign nodes to variant Godot. CPP. Simple assignment. Godot object. Cast to. Can you just cast? I tried, but it didn't work last time. If the node is treated elsewhere in your game engine, I'm gonna try something. I'm gonna duplicate this and have it be like for nodes. it's gonna be a bit specific. But yeah. And now I have the array. I can get this. And I should be able to cast this one to a node. Yeah, what is it? I forgot the type. Space observer. So something like cast to space observer, maybe. Or like I guess it's the type of array name 0. And maybe it's going to work now. No, it's not. Is it? No instance cast2 matches the argument type variant. Okay. Wait, I don't have... Can I actually just... I'm actually just going to have it here for now. And I'm going to try to make the function, because it's obviously not working. So I'm just gonna replace for now. And I'm gonna see what's wrong. So cast2 is obviously not working. So what if I just do this? It's obviously not working. So why is it not working? From variance to space observer. So maybe I have to do v equal like this. Wait, it's working now? Is it because of the pushback? Oh, is it because they're not implementing implicit conversion? I don't know. Yeah, I don't know what's going on. Wait, variant. Oh, no, never mind. Yeah, okay. So what do I have here? Call, duplicate, get. What is get? Oh, no. Index. Nope. Object data. Let me go to variant. There. So we have all of this. If this changes the table, invariant up must be updated. That sounds kind of bad. Fact array, ref base. So I mean, we have a lot of stuff in our classes and stuff. Variant, so we can take this. Avoid accidental conversion. Okay. Oh, so I have to dereference it. So can I do this? No suitable cast function from object to... Oh, this is interesting. So now I can... I can't actually. Can I do this? Oh my god. From object star to space observer. How do I know? How PTR? Get member PTR. Data. Photo gets variant pointer. Explicitly casting the variant to an object star. No. Ref. So what? Yeah, ref is a bit different. But yeah. It looks kind of the same. So there's like this operator object star. operator object store. And this is supposed to, let's check with auto. This returns, is it object? No, is it object? Okay, it's a star, I guess. So can I just do this? No, I can't. It's a bit different. Okay. Okay. And then I should be able to cast to my type. So text type observers and put v, maybe. Cast to, the function matches the arguments. Object store. Wait, really? Cast to. So for example, func space collider. And I have v. So this is working. This is working. Oh, it's because there's a pointer, right? So I have to remove the pointer. Oh, this is a pain. Can I just is pointer, remove pointer t. This looks so bad, but yeah, this is actually just not here, this is here. So we want to remove the pointer. So basically we get the first element. Or that's what you think, but you actually get the type of the first element with decal type. And the type is basically a pointer towards the space observer, but we don't want it to be a pointer. So what we do, we remove the pointer with remove pointer t, and argument types are object store. And yeah, I don't know after that. Well, actually, it should be like a value somewhere. Like, is there? I mean, I guess it's like already remove pointer type. Yeah, it doesn't really work. Argument types are object store. And it's not removing the pointer. What is it doing if it's not removing the pointer? So we have the default, we have different specializations of the template. The first one is, well, you don't have any in this case, you just reuse the same. Now, if it's a pointer, a simple pointer, then you have type that is just the type without the pointer. If it's a pointer const, then you remove const and the pointer, apparently. And same for volatile and the rest. So that should be... That should be removing object store though. Right? Like, let's split this a little bit. So we have object ptr. That's going to be this. Right? Then we have the type of the object. That's going to be without the pointer. And we can, so this is the shortcut. Object ptr. And then we can cast to the object. And this is not working. Object store. Is it because I need this multiple times? Is it like 2 times? It shouldn't be here 2 times, but yeah, that's what I was thinking. Maybe it's confused because I'm like almost sure this is good. So let's restart anyways our little Minecraft project. I'm kind of curious, but in any case, we have this here, and we also want it in the simulation group. So in the meantime, let's have get and set observers, I guess, like there. Wait, is it actually going to... No, it's not. Okay. So yeah, we have cast 2 notching overload. Consts... Could be const objects pointer. Invalid explicit template arguments. You cannot create a pointer to a reference. Oh, this is a Oh, right. Wait, what? It's not a reference, though. Wait, what? Because when I use... Well, when Godot uses cast 2. Wait, actually it's working right away. Wait, what? Wait a second. I didn't realize this. Observers. Space observer. So I want this. Right. I want to cast like this. And... Okay, oh. Okay, we can see what this is. So object is actually... Wait, what is object pointer then? It's... So the pointer is constant. It's a reference towards a constant pointer to a space observer. And here, it's actually the same. So... Oh, I have to remove the reference, maybe. So let's say I have this. Yeah, that's probably it. I have to remove the reference. But I think there's like something that removes all extents. What is that? Please, let me see what you are. No! Okay. Let me try this. Can I go... No. Yeah. Let's check the documentation. There. So, we have... If it's a multidimensional array. Oh, if it's an array. Okay, so let's remove... Well, let's not check this. Composite type. So what about the remove ones? Remove consts and volatile. So this one is kind of good, but I need to remove the reference too. Remove pointer. Remove extent. One extent from the given array type. So this is like array types. Remove const volatile reference. So this one is actually good. This one is actually the one we want. Conjunction. Okay, this is kind of neat. Remove const volatile reference. So let's do... Wait. Remove const... remove const volatile reference. Like this. And now we have... Yeah, it has to be the type, right? But actually, wait, what? Remove const volatile Const volatile. What was it? Ref. It doesn't exist. Oh. It's C++ 20. That. So. Okay. I mean, we can still do this. So we have the pointer that's going to remove the reference. The T is for type. And then we remove the pointer, I guess. Okay, now yeah, it's actually working, as you can see. Okay, so that was a lot. Oh my god. Oh my god. Okay, so now this is good. And this is going to be for references, I guess. So, okay, let's try to make it a bit more abstract now. Maybe. Maybe. Okay. So we have this. I'm going to go down and add the things at the end. Let's actually just go there. And now I can just select those thingies at the end. And boom. Here we go. Okay, so now we have this. So yeah, actually that might work with resources. Or maybe it's best not to, because reference... Yeah, let's not. So okay, we have this, we have the class name there. We have the function name there. We have the array name there. And now I should be able to do this. And this is going to work correctly. I'm just gonna check this one out. I could technically have like detect what the type is and try to do things differently depending on that. But yeah, I can actually do that. Wait a second, because this is just the conversion, right? I have to convert to the object, right? So I have the decl type. So like object store, or maybe not. Yeah, let's actually have something a bit different. So let's say we have this. Let's make it work in both cases. So, in the end, what I want is object what? I guess I want to remove the reference in any case. So we have like this. Actually, do I? Let's maybe keep it. So we have... Wait, is it object actually? Maybe all I need is a function that's like get value. Okay. So get value from this. From the variant, and this one is gonna be different, a different specialization, template specialization, depending on the type of the object and whether it's a pointer or a ref, right? So can I have it like be local? Actually, I don't think I can. I can make a class locally though. In C++, you can't make functions locally. You can't have a function inside another function. You can actually make a lambda expression, but it's a bit different. You actually have templated lambdas now, but it's like C++20 or kind of advanced. Let me just check. It doesn't seem like I have access to C++20 because I don't have const volatile ref, like remove const volatile ref. Lambda template. C++20. Yeah, it's auto until that. So I can't have like specializations anyways. So I'm gonna make a class. That's gonna be a helper. I'm making it a class so I don't flood the namespace, but like the scope basically. I don't want a random class with a random name hide or like prevent me from potentially make another class of the same name. So this is my helper. I guess it can be a struct because I just want things to be public. And this is actually just going to contain the template. I'm never going to instantiate this struct. It's just going to have a static function inside of type t. So this is get value. And I'm gonna return a type, which is going to be I guess it depends. Let's have this, I guess. The template declaration is not allowed. So what I want to return is actually not the pointer. Yeah, what do I want to return? Yeah, maybe I'm just gonna have auto for now. And here it's gonna be very important though. A template declaration is not allowed here. Is it allowed here? It is not. Oh no. Oh no. ++ templated class in function. Yeah, maybe it's not inside functions actually. Defining a local class inside, like this, but it doesn't support templates. If that function is a template, the local class automatically has access to the function's template parameters. Prior to C++11, local classes could not be passed as template arguments, but this is fully supported in modern C++. Oh yeah, because this is a templated function. Okay, yeah, this is because it's a templated function. So it doesn't seem like I can actually do that. At least I can... No, I don't know actually. Feels like I'm stuck. So I'm just gonna have this like this to prevent name flooding. I mean, it can just be... I don't need it to be a struct if it's going to be in the global namespace. So I'm going to return auto, I guess. And if this is a ref value, then I'm just going to return the value because it seems like it's fine like this. Maybe it's a reference in this case. And if... Actually, yeah, that's not how it works. It's template specializations, right? So this is going to be T. And this is going to be the case where we have a reference here instead of T. And then we have the case... So this is basically undefined. Can I just have a static assert? Or maybe... Yeah. Something like this. And then we have the case where it's it's a variant, I suppose. Well, I guess it's like casting actually. It's already a variant though, so it's a bit complicated. So it has to do with, it doesn't have to do with like the inputs because it's always going to be a variant. This is a variant. But here we have, so this is a variant. But we have the case where we have a reference toward something like this. And we have the case where we have a pointer, right? And this one is actually just the type of the object without the reference, maybe? Is it? Maybe there's like const though. There's like the const thing. So if this is just object ptr, well, in this case, I guess I want to cast the value to an object. Oh, but cast2 is not a function from this, right? Oh, this is a bit complicated. Well, cast2 is like a member function, right? Like a function from, oh no, it's a static, oh, it's a static function. So I can just do this. And yeah, now it's not working because, or maybe it is. I don't know. In this case, I guess it's auto store. Is it? Wait. No, I need this. Yeah, okay, I need this. So value.operator this. So now I have the pointer, and I want to cast to the same thing but without the pointer. So t. Oh, right. This is gonna be object, row object, maybe? Well, row t. And it must be, yeah. Can I have this? And I guess it's gonna be row t. So, okay, this is a bit tricky. Well, it's not really, but it's basically going to be t. Wait, t star. Wait a second. So if this is a pointer, yeah, this is actually already t. And maybe without the, yeah, anyways. And I'm gonna return t. And I don't know if it's going to work, but yeah. So let's say object ptr, remove reference, okay. So get value. To function template auto something get value t variant is not working. And then we have t star get value t, and argument types are variant. Yeah, this is a variant. I don't get it. Oh, more than one instance. Okay, never mind. So, okay, I have to do something about it. Is it because of this? Can I just do it? Yeah, I have to. I need this. So C++, how is it called? Template specialization, where, well, I mean, yeah, it's already a specialization. So I think it's just that it's not, well, no, it is finding this one, wait. So gets, can I just have like a void? More than one. So we have the void, we have the auto, and we have the other one. And they all work for some reason. Even though it's not like a ref. Variant. Object PTR is space observer const. Wait, no, none is working. Wait, it's const though. Yeah, why is it even const? Can I just get? I guess I have to use get, right? So now it's not const anymore, which is good. But there's still going to be some problem, isn't it? So space observer star. I have my specialization. And wait, I'm doing things wrong. So we have this. We have type name T. And then we have this with void. So this is a explicit full template specialization. What about a partial one? Partial template specialization. So we have this. Oh, I need multiple classes. Is that it? So then I specialize. What about if I only have... So yeah, this, for example, I can specialize some of those. Error. Name lookup. Partial ordering. So yeah, every time it's like removing a class. So I don't know if I need like more arguments somewhere. So template specialization for pointer types. Yeah, I mean Godot had this, right? So you have oh, is it because of functions? Or maybe because I know that templates work a bit differently, whether it's like a function or a class. And as you can see, function template handling. Overload. So yeah, it's an overload, and this is a specialization. So it's technically a bit different, I suppose. But it should still find the right one. So then you have concepts in C++20, but yeah. Oh, this is so nice. If you need to handle const. Okay. I don't need this. So yeah, basically this should be working. Right? But it isn't. It isn't. Or is it because... Wait a second. Right. No, not right. No, okay. Okay, wait. Yeah, okay, I get it. Yeah, okay, this is it. I think I get it. Okay, as I told you, for functions, this is an overload. That means it's about the arguments of the function. But for classes, it's a specialization. So it's about what's inside the template thing. And here I have like I'm trying to have some partial specialization for functions, but it's actually not working because it's only working with overloads. So I need it. I need to make it a function. So helper, let's say, yeah, let's just have this for now. It's gonna be some bad class, let's say. We're gonna have the get value. Then we're gonna have a specialization. So this time it's going to be this. Wait. Like this. And inside I'm going to have the same thing, but without this. And I can just copy this with helper. So this time it's like T star or like a pointer. And I'm going to have this inside. And this is gonna return T star. And I can remove this. And now what I can do is I have my helper. I can do, yeah, I need the template argument. And I can do a get value. And now is inaccessible. Okay, this is working. It's because it's a class. So struct. And yeah, now it's working. Okay, that was a big ride, but that's how templates work in C++. I know that's a lot. It's been a while actually I've used those. But it seems to be fine. And now the good thing is we actually don't need but I can remove this. I can remove this. I can get the variant. And this is just a single function. So I'm just going to copy everything. I'm gonna go back in my helpers. I'm gonna go there. Helper. Maybe I can have like a private namespace or something. Helper like namespace voxel helpers, so I don't pollute the global namespace. Something like this. Here we go. Now I can get from the namespace. So this is a bit long, but this is fine. And now this function is going to be inside this macro. And this is going to be independent from whether it's a reference or an object. And it's going to implement the setter right away. So I can remove. I can do this. Boop, boop. Oh. Uh-oh. Maybe not. Okay, and now I can. Boo, here. Boom. I have the class name. I have the function name. I have the array name there. And this should be good. And now I should be able to remove those. And and I should be able to use this one in any case. So it's, you know, there's not going to be any problem, no matter. Well, I'm not going to get confused about which one to use. I'm not going to use the wrong one without realizing it. So it's neat. So yeah, that was a long thing just for that, but yeah, and it seems to be working fine if I run this, for example. That was long though. The thing is also it's a template, but it's also in the header. So it's like rather short, right? So it should be inlined and kind of optimized, probably. And I have a syntax error. Never mind. What is that? Instantiation. Wait, what? What's the problem? Recovery. Unexpected token. Is it not how you have static casts? Maybe it's just... Wait. Wait, oh, static cast? No, it's a static asset, my bad. Wait. Let's check the documentation. So, example. Oh. Okay, it has to be inside. Oh, got it. So it's false. For example. I don't think I need to put the error message, but yeah. Well, this is basically unimplemented getter, or like unimplemented setter. Static assertion failed. Oh no. Where is it getting used? So this is failing somewhere. I don't know where though. So it's when compiling like chunk space, for example. You also have chunk space collider. So maybe this one? It's not working for this. So is it gonna work now? Because it's clearly the same, right? Unimplemented. Unexpected. Wait, what? Yeah. Should be this. Should be this. I'm spending so long on that. But I really don't want to write my setters and getters myself. I really don't want that. Okay. Unimplemented setter. So I mean, it's always the same problem though. I can't have... Can I like have my templates arguments or something? Wait, what is... Wait a second. So it's there. So the problem is there. Oh. So if I do like ref and I remove, well, and I search and remove this, well, replace this, So I guess it's only for references that there's a problem. So I'm gonna copy that, and I'm gonna try replacing. So what's the problem? Oh. Actually, there's a problem in any case. Oh, because it's always... Wait. Am I stupid? Am I stupid? Is it that I just can't put that in any case? Oh, wait. Okay. What if I just remove that? Is it just gonna work out of nowhere? I mean, maybe it is. Yeah, that would be kind of stupid. But yeah, I basically didn't want this function to get called. Like this class to get called. I wanted it to be like incomplete, like abstract. But I don't remember C++, well actually, unimplemented setter. Right, yeah, no, I have to remove this one. My bad, I modified the wrong one. I mean, it should be, you know, the same, I guess. Okay, building targets. Good. Do that. And yeah, what I wanted to do next was put observers in the simulation groups. Wait, it seems to work actually now. Linking program. Oh, okay, it's working. It's actually working. Okay, so this is great. This is neat. Yes, done. Okay, this is neat. So it's working. It was just my static cast. So let's go there, let's clean things, and by that I mean remove everything except the macro. And same, well, it's actually already the case there. Okay, this is perfect. This is perfect. And now, and now, if I want to implement the setters and the getters for the observers, I can just go in the C++, just copy this actually, here, change the class name, and really get observers, and it should be good actually, right? I need, yeah, okay, it just needs the function. 2 voxel helpers, it's like there. And here we go! And it should be good! I love it. I also need... this. Get... Wait, yeah, set. I'm gonna have sets too. Because now it's working. So there. And I'm just gonna copy this into my simulation group. Ooh. So this one though, and it should be good. Yeah, so now I have the observers, and we're gonna try to debug our collisions a bit more. I mean, I don't think it's actually working anyways. I have to find what I forgot to implement. That actually happened, well, that actually happens like kind of a lot with me, is that I try to do things and then I'm surprised it doesn't work, and it's just because I didn't implement something. What is that? Object PTR being compiled while compiling class. So this one is not working. Why? What's the problem now? Object store. Get value. Types pointed to or unrelated. Okay, so Cannot convert from object star to... Okay, so T, what is T? What is... I think I know, it's just because I didn't include the header. So that's fine. Observer. This is fine. So it's working well now. I can actually trust the macro now, which is good, which is neat. Please. Please work. Okay, so I have all of this. I can generate the colliders if I want. I have, well, this is my simulation group, and I potentially want to update things. So in the space, I can override this. I can spawn this, of course. I can update the colliders. So yeah, this is what I kind of want. Update the colliders from... Okay, yes, it's abstract, right? So then I can go here. I have the update there. And I can implement it. Well, it's already implemented, kind of. It's not actually implemented. Okay, yeah, that was what I needed to do. So if I go here, or here, I can update, but it's actually not going to do anything. And instead, I can also generate colliders right away. Probably. And if I check there, it's just gonna spawn everything needed. Chunk collider instance. So I spawn it from the... Well, I spawn the shape, I guess. Wait, I'm not... Yeah, what about... Oop. So I have the instance, but I need to set the instance, right? Like this. And this is like a sign to the shape. So the shape is gonna be this. And I'm just gonna restart. I don't know if Godot has hot reload. I mean, it probably doesn't for a module. Hot reload, VS Code. Go to CPP. So yeah, it's only if it's an extension. Yeah, that would have been nice, but yeah. Editor only feature. File swapping. Yeah, and what about CPP module? Yes, CPP extension. Performance. Yeah, that's what I thought. Because there's like a lot of callbacks with extensions, right? Because it's like through a DLL, because it's getting hot reloaded and stuff. Those performance depends. Heavy math loops. We need performance because they are statically linked. Yeah, that's it. But the other one is, you know, has another head. Makes sense? I mean, it's not that big though. Well, yeah. So if we can't actually run it. Gets collider. Wait, what? So okay, this is invalid. So chunk get collider. Chunk. And you have get collider. And this is not valid. Yeah, why is it inverted again? Okay. Okay, what about the rest? Already has property chunk space. Yep. So it's like visual and collider. And already property updates colliders. So chunk space collider. Already has updates collider. Wait, what? Is it because of the parent? Wait, there's no parent. Chunk space. Wait, what? Oh, I think it's because of the child. Wait, actually, yeah. So if we go there, we have update colliders. So let's remove this. And then we have invalid setter chunk collider instance. There. Then we have invalid property for property space. So this one, space. Right. It's like set space collider. We have space collider of type chunk space collider. Okay, this should be good now. Should be good. Should be good. Okay. So you know what? Let's make a document actually in the meantime, because I actually don't have a big one, let's say. I have like ideas, but I don't have a big document for the game, and I need an art style, I need the actual gameplay, and all of those things, right? So let's go in, what is it? Games? No. Game, no. It's progs. Oh, my indie games. Voxel game. And yeah, let's go there. So okay, we have this, we can run again. It should crash probably, but there shouldn't be any errors this time. And actually it's taking more time than before, so maybe it's actually going to... Never mind. So there's a problem, obviously. Let's just not do things with collisions. Okay, so we have the donut without the collisions, but this is good. So now I'm going to just spawn the new simulation group. Is it gonna be... Never mind. Okay, so it's spawning the thing. Now I'm going to... I guess I don't need this to call generate colliders. So I think this is the one that's crashing. Realistically. On another... Well, I mean, of course, yeah. That makes sense. So let's go... Let's go there, because it's gonna crash. 100%. So in the space... Yeah, it crashed. So we have the spawn simulation group. So we instantiate it, we add it as a child, and we add it to the list, so nothing crazy. Then we go there, we try to generate. So, oh, I'm not setting space. I'm not setting space. So let's have a little check. Air now. With an editor message. Maybe. Places now. Okay, I tried to get the space from this, which should be good too. Let me... Because yeah, it's unlikely. Can I think I have something for that. Well, I have the cast. That's not really what I want. You know what, that's fine. It feels like such a shame to keep the conditions, but... Let's keep this, I guess. We can always replace it afterwards. So, okay. And if I go to here, I have the simulation group. I want to set the space to this. And what else do I have to put? So observers. I can actually set the observers from GDScript. So that's not a big deal. And yeah, should be good. And I mean, I'm not really using the observers right now. So it should be good in any case. I have to improve things with that afterwards, but yeah. I'm thinking, yeah, let's open the document while it compiles. So we have this. The ideas I had were, well, where, you know what, let's have a category ID. I got so many things. So IDs. We have different planets. So we have the flat torus. We have a cube sphere. We have infinite death. Well, planets with infinite death. We have planets with cubes. We have planets with octagons. Well, that's not platters. Planets. Octagons is... How is it called? English octagon. It's octagon, right? Maybe without the E in English. Octagon. My bad. Octo is 8. So that's why. An octave. I guess octa is 8 too. Is it? Yeah, it is. Probably. So we have this, we have non-Euclidean planets with a curvature of 0, but portals to a space with a negative, well, with a different curvature. And about this, it's basically going to be, yeah, I'm going to write just a bit about it. What was it? Oh wait. This is it. So we have like this. So we have this. And yeah, a big cube here is one or multiple chunks. Is it? Yeah, to prevent the player from seeing distortions too much. There are objects that can't be destroyed at the vertices, basically. Made out of, well, yeah, this is good. So it's distorted chunks. And yeah, should be good. So that way the player should always be able to see squares and have the squares be linear. Actually, it's going to be a problem still at the edges because it's going to follow a different trajectory. I'm not sure much about how it's going to turn out. It depends on the projection. That's an idea. Anyway, let's try to generate again collisions. This, wait, actually just loaded. We have this, let's go 1. Okay, we have this. Let's go 1 again. So let me just see the collisions. Ooh. Okay, wait. Oh, it's there. It's so small. So we have this little one. And we should have colliders somewhere. But apparently we don't. Interesting. Oh, because... Wait, what? Oh, right. Okay, can I... Okay, if I go there, I have 0 observers. Space is not set. I have a simulation group, but wait. Chunk space collider. So I guess I have to change the type of this guy. Do I? Cube Torus Chunk Space Collider. Wait, so this one is good. Oh yeah, it's just that I don't have anything registered in the class below that. Okay. But yeah, I'm not setting... So yeah, I'm actually setting the space though. But it doesn't seem to be assigned. Which is a bit weird. Space. What about... Well, yeah, this should be good. Let's go see in... Well, actually, do I have any errors? It doesn't seem like I do. Okay, so this is the collider. Okay. So when I go to the parent, I have this. And I have the space. And I should get it and set it. And this is assigned properly to the space. Well, to the right getters, I guess. That's what actually matters. And this is weird. I mean, there's no error though. So, I mean, I guess that's supposed to be correct. So we have the collider. And we have... Oh, that's the remote. Never mind. Yeah, every time it's the same. Oh, so I do have the chunks. You have the different coordinates. Yeah, I mean, that's... Never mind. Collisions. So we have the player, and then we have the simulation group. And inside, we should have the rest, but we don't. And the thing is, we want our observer to be inside this group to collide. Actually, we do have... Never mind. Yeah, wait, what is that? Collision? Because we have... Basically, there's a gizmo there for the group, but it's just a square. So I'm not sure about what it's trying to be. It's like not really. I mean, I guess it's generating things, but as a child. I'm not sure about that. Generates colliders. It's not triggering any... So if chunk doesn't have a collider, do they? Do they have a collider or not? It's not spawning anything. That's what's crazy. Assign adds child. Yeah, you have like literally the adds child. I mean, I can always like reset it. Well, like remove this and see how it does, but yeah. But yeah, we also have the player though. We need to move the player there. To the simulation group. So it will be something like simulation group.observers equal the player. And I have to move it there, kind of. Like generate something. Yeah, well, it's a bit different, but yeah. Let's just have the player. Player collision. It's a nudge, really. So locally we have... Well, locally. Yeah, locally there. We can select the player. Then we can do... Bidu. And I guess observer is like a new class, right? So it's a bit different. But I guess we can reparent to the simulation group at least. So we have like the same collisions, the same colliders, the same world, the same simulation. And other than that, I mean, I can try removing this, I guess. Chunk. Yeah, what about the chunks though? Let me see the chunks. Remote. Chunk. Collider. Collider is no. So visual is valid though. So there's a... Oh. There's a problem with... Wait, but I'm getting there. Generate colliders. So what's wrong with this? I'm not sure. So we have one collider. Remotes. We have the player. We don't have any observer, but that's fine. We don't use it for now. And yeah, when I... Simulation group, generate colliders. It's getting cool. This is getting cool. This is in ready, right? And yeah, it's like generating the chunks and stuff. So generate colliders. There's no error. There's no error. So it's not this. And oh, if it's not okay, if it is, no. Never mind. I'm kind of stupid. Okay, I get it. Okay, my bad. So we spawn from the chunk, so that means we assign inside. Yeah, okay. To do spawn at construction. Chunk shape group. What? What is that? Wait, what? Yeah, what is actually this? Oh. Oh, never mind. I get it. Maybe. Chunk shape group. Yeah, I get it. So we have the chunk. Yeah, because you have one chunk in the core, but you have multiple representations. So it's about this. Okay, so we can close, and now it should be good. Let me be right back. Let me put some ads and have a little quick break. Okay, I'm back. Back. Okay. So now we have our engine. We can run our engine. I'm saying that as if it was As if I made Godot. But yeah, we have the collider. And now if we check remote, we have the collision space. No, we have the core, I guess. We have the collisions. We have the space. We have something. Oh, yeah, we have shapes because it contains the different, well, collision shapes that have been created, like the resources. Wait, they don't have... Wait, what? They don't actually have a shape. Wait, that's kind of bad, isn't it? That's kind of bad, isn't it? Okay. But then we have the simulation group that is going to use this collision shapes. And inside we have, well, the shape that is empty apparently. So that's a problem. That's a problem. But it's basically just a question of assigning a lot of things apparently. This is null too, and it shouldn't be. So chunk collider instance. Let's go chunk collider instance. Do I have any error from that? No, I don't. So there. Well, not there actually. When I'm creating it, so I register the class, I name new. Yeah, there. So I generate the colliders, I guess. And I try to assign a shape. Is it working though? Chunk shape. So I should be creating it, but for some reason... yeah, anyways. So let's set a few other things. We said that it's missing the chunk and the space collider. So space collider is just this. Actually, it's not. This is a simulation group. Wait. Maybe I want the simulation group. That might be for the best. I mean, yeah, if I am I going to always have a simulation group? I guess I'm always going to have it. So let's go there. And instead of the space collider is going to be simulation group. Right? So then we don't have this. I'm just going to comment it for now. Wait. Get simulation group. Same there. In simulation group. Same here. And I return this. And I forward declare it. Yeah, I guess I can do the same, like there with chunk, there with chunk shape, and there with collision shape 3D. Okay, here we go. And even maybe that at one point, but yeah, not now. So we have this simulation group. I am going to remove those. I mean, it would be good to have like a getter though. But yeah. Set space. So this is going to be... Wait a second. Get simulation. Yeah. Well, set simulation group. Same here. Correct class. This is simulation group. And the class type is this. And I'm just going to have maybe a getter. Am I? Nah, I'm not. So in here, in the simulation group, I have the space, and I have getters for that, so I should be able to retrieve the space from this. And now I can set the simulation group. And what do I need? So the space, I removed it. I need the chunk though. I need the chunk. So this, that's chunk to this one. Should be good. I mean, the shape is actually about chunk shape. Yeah, it actually already has a reference to the chunk. Because this is just an instance, right? So technically I can remove this. Collider instance. I can remove the chunk. I can remove this too. Remove this. And yeah, it's going to be very minimalistic, but it's gonna be fine. It's gonna be fine. And that's why we also prevent errors, I guess, kind of. Let me... So wait, this is... Wait, I don't have... Can I go? I can't. Yeah, let's go there. Right, it's because it's... No, I don't know, actually. So these references should be set, or like the new references, I guess. Now this one, this is empty. Which is a problem because I'm doing the assign, and it shouldn't be like this because we have chunk shape, but this is just shape, and this doesn't seem to have a script. Chunk collider instance. Yeah, okay, no, this is fine. I just add the new collision shape down, and yeah, the actual problem is that that shape should be basically kind of this, really, but there's like a connect, right? Update shape. Let me just get shape. Let me just do this. And I'm going to I mean, I guess this is fine. If this is null, this is going to be set to null, which is fine. And if it's not null, it's going to be set to something that's not null, which is fine too. There's just this thing, though. Connect to this. No, wait, no, this is the name. And this is calling the callable. Update shape. And this is supposed to call this. Okay, and it wasn't calling the function from the signal because I'm generating shapes directly for now at the moment with generate colliders, maybe like here I have the spawn chunk shape, I have the create, I have the set colliders. Wait, I'm not chunk shape. Am I generating anything here at any points? Generate shape. I should be coding this somewhere, right? So like, what if I... It's actually never getting called. This seems like a problem. And then we have async things, if we want. Async generation. With the dispatch and stuff. Generate shape, async Dispatch. Let me just check this one. And yeah, this one is getting, actually it's not getting cold. So yeah, this is a little problem, but this is fine. We can generate shape. Oh, not in the instance. In here, maybe? Do we? I mean, I guess, yeah, for now. Spawn. Wait, spawn. And I guess it depends on the priority, though. Yeah, let's maybe have something like shape generate. Okay, I don't have. I have to include it. Modules, voxel, collision, chunk, shapes. Yes. And now I can generate shape. And it should be fine. It should be fine. Maybe. Actually, I just wanted to check something. Where was it? There's like an update somewhere. But I don't have it. Oh, it's there. Yeah, instead of doing this, I want to update it here to call the same function, so I'm not missing anything. Collision shape, set shape. Yeah, should be fine. Maybe I need to do that after adding it as a child. Or maybe it's going to cause problems. Well, actually, never mind. It should be fine. Okay, let's open the engine. And let's actually open my documents in the meantime. Yeah, if you have any questions, again, feel free to, ask and stuff. So, player experience. I'm not sure about this. But anyways, I'll be going about the visuals. I actually discovered... I actually did some research. And... Wait. Oh no. And yeah, I discovered a video that's like incredible. I have to show it to you guys. Because it's really incredible. But the guy basically worked on some project that was incredible. And it was maybe 5 years ago. And he just stopped. So I was thinking about having an art style, maybe trying to make it a bit similar, not the same, because I don't know if I'd be able to, because the project is, I think it's like with Ray marching or something like that. Wait, it's not. Wait, I have to find it. Oh, it's there. Found it. Let me just add this in my new playlist, Voxel, that I made just for this project. And yeah, look at this. Look at this, guys. Look at how good it is. It's looking pretty well. I mean, it's just Fluid simulation now, but let's go on the channel. New voxel engine reveal. Yeah, it looks like pretty neat, right? I mean, it doesn't even look like voxels, really. So that's why I'm not going to have the same, obviously. I don't know if it's like generated either. I don't think it is. What was that be? Dot. But yeah. And I mean, maybe you can't see it well. I mean, it looks pretty neat. That looks really cool, right? And yeah, I don't know about, like, you know, there's like compression with Twitch and stuff. I haven't actually seen this video. But it's basically kind of like very small little cubes. Maybe you can see it a little. But yeah. Ready? Oh, Ravioli! Hey! Hello! Wait. Ravioli was she streaming? Thanks for the follow! Hello, bonjour, bonsoir, bonjour. Hello. Hello, welcome, people! Yeah, we were watching this video because it looks incredible. And it's actually some kind of voxel world, like Minecraft. Parle en français, ok, bonjour. Oh. Mais oui, baguette. Okay, wait, he's too cute to follow in this thing. I only follow people under 5 foot. Ok. Parle en français, tu veux vraiment que je parle en français, hein? I was in your chat and raiding you too. Incredible. Both at the same time. Watch it. And yeah, it was actually... You know what? I can actually show you things, actually. Maybe I can't. Wait. No. Why is there a problem? Undefined class. Okay, I can solve it. I don't know where. What is that? Okay. Okay. Je t'aime. Oh. Drink. Make me. You know what? I'm just going to... Oh, so many sounds. Ah! Good morning and happy Danish Constitution Day. World Environment Day and National Donut. I have a lot of donuts. I don't know if you knew, but this whole stream, this whole game is actually about a donut. Is that a coincidence or... Thanks for the follow. Oh my god. I do. Sorry. We'll never... Aww. What is the difference between voxel and, for example, PS1 graphics? Okay. Okay, so PS1 graphics is pixelated. So PS1 pixelated graphics. It's basically that you don't have enough pixels on your screen to render correctly. And the pixels are always going to be, you know, aligned. Like on 2D on your screen, right? Like horizontally and vertically on your screen. But voxel is when this is a world made out of... it can be cubes, but it can actually be octagons, for example. And, you know, you can have like some perspective with it. Minecraft is voxels. Yeah. It doesn't have to look like voxels. Yeah, like voxels... Like, it's actually a method. Voxel is a method, and it can be used to have a low level of detail of objects that are very distant, and that don't need to render all of their rendering data, like all of the triangles. PS1 is very low polygon models. I thought in PS1 they just use polygons with low poly textures on top of them, like GoldenEye. I mean, all of the... I mean, most of the games use polygons. There's like something called signed distance fields, which can be shortened into SDF, and in French that means homeless people. So let's not use French for that. But this is basically a way to represent shapes using mathematical equations. And with that, you can render things on the screen too. You actually have some pretty nice time distance fields, I guess. And yeah, it's used for collisions too a lot as an approximation. But usually in games you use triangles and you use the rasterization pipeline. So for the rendering part, rasterization, it's basically going to be the same as in... Well, I guess you had like some cheats with like Doom, for example, but it's basically going to be this pipeline. So you have a list of points, a list of vertices that you put in your vertex shader that is going to make triangles from how you define them. Then you have rasterization that is, well, displaying the triangles, well, that is converting the triangles that are theoretical into pixels on your screen. Then you have the fragment shader that's like going to apply some post-process on your pixels, like change the color and stuff. And then you have, you know, maybe applying the new textures you made onto, you know, the window of your application, or, you know, that kind of stuff. Yeah, I actually have to show you. Where was it? It's here. Collision simulation group. So wait, it's actually already there. H. Where am I using that? Okay, there. So no, that's not simulation group, never mind. So we have modules. So yeah, right now I'm actually using Godot, as you can see, but with this project, since it requires some performance, I'm actually doing it in, well, a lot in C++, inside the engine itself. So like we have everything about the engine here. We have static body 3D, we can see the class, we can even see the implementation, and we have like some debugging to some degree. And yeah, so we have this, we have the simulation group. Now I should be able to compile, and now I should be able to show you what I'm actually doing, and why it's amazing, and how I won't be able to have something like that, but that's fine. Let me read a bit what it said, sorry, I'm gonna read the comments. Wait, hey pro, hey, Gabe, hey. You didn't tell us you speak French, did you, JC? Oh, Google Translate does who know. Wait, which one? I saw PS1 has some hardware thing which causes distortion on certain textures at certain angles. I mean, it's like probably, how do you call that? Like an optimization. I don't, is it like the hardware? Oh no, I know what this is. No, this is actually something that is like in any game to some degree. It's like called, how is it called? It's like texture, like when you view it from the side. I don't know, wait. Texture viewed from the side problem. It's like on Learn OpenGL you have this explained. It's like the UVs are not interpolated correctly, so it looks distorted, I think. Can I? Let's go to let's go and learn OpenGL. So this is basically a website to learn about rendering that is very good, that I recommend if you want to learn that. And you should have something like textures. And when you view it from the side, maybe at some point, maybe not. I don't know, but it's a setting basically. It's a setting. It's just that the PS1 didn't have this setting, I guess. But it's not like unique to PS1. Texture distorted when viewed from the side. UV stretching. Perspective distortion. Anyway, it doesn't really matter. So many comments. Let me catch up. Malgré mon nom, mon français est médiocre et je ne parle pas bien. I mean, it's fine. As if it's used in medicine a lot. Oh. I didn't know that. Mendelbrot. I actually saw a Minecraft-inspired game that uses octagons. Let me see if I can find it. Yeah, I would say there's like a lot of games like that. Well, a lot. Maybe not a lot, but a few prototypes. All my eyes produce SDFs as output. Oh. Polygons, yes. So in my dummy worlds, polygons are not accurate shapes, but rather close thing to actual voxels. Wait, what? Close thing to actual voxels, especially with the textures on. Voxels allow a bit more customizability to create shapes that are mostly as realistic as the real deal, right? No. Wait. No, that's wrong. Okay, so basically, polygons are triangles. Polygons are triangles. So with that, you can have like a lot of different kinds of models. Like most games you think about are made with triangles, even if you might not like see it because the triangle is like really small. And voxels, it's about instantiation. And it's about like making something like infinite, for example, because my voxels are made out of triangles. So my voxels are polygons. So like polygons is something that's a rendering that the renderer is going to use to show to the screen with the rasterization pipeline, because you have other rendering pipelines, but let's not talk about those. And voxels are when you have shapes. So, you know, with Minecraft, it's like cubes that can be spawned and despawned depending on the need. And like you have hierarchical voxels that can add like some precision and stuff. But in any case, in principle, it's something that can be spawned and despawned. And that's like, or maybe that's not in the definition, but that's something that's the same shape that is repeated a lot of times. Yeah, I would say that's the same shape that is repeated a lot of times, but next to each other. It has to be next to each other. So, for example, you have voxel, you have cubes, so you have a lot of cubes next to each other, so that's like voxel. And then you have voxels with octagons, octagons. And in this case, it's actually this one, but with octagons. Hexagons. Yeah, like this, for example, right? That's the same shape repeated next to each other a lot of times. Same here, right? So it's a voxel too. Found the game, it's called Planetsmith. If you wanna check it out, it's a voxel-based game inspired by Minecraft, but there are different planets. Oh, I wanna do the same so much. Okay. I've been texture warping based on quick search. Let me search that too. Yeah, that's it. Linearly interpolates textures instead, in screen space instead of using the depth, right? Yeah, makes sense. Yeah, it's something you can have this problem too when you make the rendering yourself. We had this problem when we made it like in college. That's like, you know, normal. That's like a step of rendering that you have to fix, or like you have to take into account like the perspective. And yes, I had, wait, what was the name? Planetsmith. Boo. Okay, let me just... So yeah, okay, I can actually show you... Wait, that's... Oh wait, it's working, we have the collisions. Wait, that sucks, does it? Okay, so let me show you something incredible now that I was working on. I don't know if you saw it, Ravioli. Okay. This is getting commented. And... So basically, I'm generating not an infinite world like Minecraft, but okay, the collisions are taking a lot of time to actually get generated. This is fine. This is gonna get generated. We're going to go through it. Wait, this is actually crazy. Wait, what's the deal? Wait a second. Maybe I should remove the collisions. Can I be honest? I feel like my brain can't handle this information. You're doing an awesome job. Mad respect, thanks. Thanks a lot, I appreciate that. Let me remove this. Let me remove the collisions for now. We don't need them anyways. Well, we kind of do, but not now. And I mean, yeah, if you wanna know anything about game dev, feel free. It's like my job, not as an indie, but yeah. And thanks for I chat GPT. Thanks for the follow, GPT. So yeah, I basically have some donut, okay? But this donut is made out of cubes, as you can see, and I can even break those cubes. But as you can see, the cubes are, well, they're not like real cubes because they're like a bit, you know, the surface is not a flat, right? Because it's a donut, so it's like kind of obvious. So when I dig down, obviously I'm going to have rectangles, right? And that sucks. We can all say that, right? And the reason is like, you can actually see it very easily when you look at it from the inside. Like all the cubes are on top of each other, but they all go down to the center of the ring. So that means you get some rectangles that are just really bad, right? And basically what I did is, well, I removed it. Because why keep this if you can just remove it? And you're going to say, wait, how can you remove it? It's like a donut. Let's go there. I'm going to switch to this view. And as you can see, I can work on the donut itself, which is pretty neat. And another thing is I can also dig down. So we're gonna dig. And as you can see now, it's a cube. We have cubes. We don't have actually rectangles. We have cubes. But we're still inside the donut. We're still inside the ring, right? So that's like kind of crazy. And yeah, if you look at it from the inside, you can see that there's actually, wait, so this is a small chunk. Let me go maybe there. Wait, this is a bit weird. Oh yeah, this is inside of the donut. That's why it's so small. Let's go on the outside. So we can look here. Perfect. And you can see that the cubes still go towards the center. But when I get closer and closer, it's actually getting distorted. And it's actually turning into cubes as I get closer and closer. And something that is really fun with this is, even though it looks like, you know, normal cubes, when I dig down, for example here, you know, it's still cubes. But I can also dig on this side, right, forward. We're gonna continue like this. So I'm going straight, right? I'm going straight. This is a straight path, okay? And the thing is, at one point, that might be in a lot of times, but if I continue going straight, okay, just a little bit more. Whoop. Please. Ah! Okay, can I maybe dig faster? Okay, here we go. I just go back to the original position. I just looped around the donut, well, the inner circle of the donut. And like I can go, you know, in a straight line, but as you can see, it's like spherical in the distance. And I'm just going to go back to my original location. So this is the block I broke earlier. And yeah, I can just go up again. And if I dig in the other direction, it's gonna be the same. At one point, it's going to be a very long path, but at one point I'm going to go back to my original location. So this is actually pretty, you know, pretty funny. And yeah, and the goal is to generate terrain on that and to make the donut bigger and bigger. Right now I'm generating everything, like the visuals, like all the chunks are generated, but ideally I want to spawn and despawn. And for collisions, It's taking a long time because I'm generating everything too, I guess. But yeah, another thing that is very tricky is how our collisions how our collision is going to work with all of these deformations, right? And it's actually a Euclidean space, so it's actually just a normal grid. So like if I switch, you can see that somewhere, oh, I don't have collisions anymore, right? So what if I decide to generate again? So it's gonna take a while, but this is fine. In the meantime, I'm going to go look at Planet Smith. That's Ravioli, recommended, I guess. Like, told us about. And oh, octagons. I see. That looks nice. I feel like the rendering could be... Well, basically I'm trying to see how I can beat this game. And it's like with the rendering doesn't look good. For now. New Planet Smith devlog. Kickstarter is live. Wait, what? 900%? You escape pod malfunctions and crash lands on... No. Okay. Because I basically want planets like this too. With like octagons potentially. Like mixed cubes, octagons, and maybe other shapes. I want something really flexible. And I want different planets with like different, specificities with each planet. So you can fight. Okay, so you can make a spaceship. You can make a rocket. Okay. Okay, I do want this too. I wonder how you can make this though. Oh wait, actually you crashed, right? So maybe you have the rocket from the start. Do you? Wait, is that... Never mind. Massive wells. Oh, that looks fine actually. Well, I mean, it seems like there are some, structures that can be like pretty interesting. True spherical worlds. Yeah. Yeah, so okay, so there is... So yeah, it's spherical. So it's very similar to me. Yeah, there's still like a lot of features that it doesn't seem like they have and that they plan to do, that I want to do. So let's see if we can make it. But yeah, I would say voxels are getting pretty crowded. Like there's a lot of prototypes and, even, I guess, games now. You have like Hytale, that was a bit too ambitious, I suppose. But yeah, you have Planet Smith. Every world in the solar system is fully procedural. With climate. Okay, biome placement. Yeah, I was interested in that. Earth-like worlds. You have other things. And yeah, you have... Never mind. This is not voxels. Yeah, I guess this guy... I mean, I can understand if this is pretty popular. Can I check the Kickstarter? Is officially live. Oh my god. Oh my god. Oh my god. So much money. I mean, yeah, this is a lot. This is a bit crazy. Seamless space travel. Build your own rocket. Yeah. So yeah, you can build the rocket too. Hexagonal building freedom. So yeah, it's only hexagonal though. I think hexagons are a bit painful. That's why I'm using cubes, because I think it's like a bit painful to actually do things in that kind of world. Like, how can you dig forward, for example? Like, you need the size of the block to be, of the voxel to be. I mean, it can be good. I mean, it looks good though. I mean, it needs some shaders, but it has the potential to be very nice. Okay, maybe I should stop making while promoting someone else's game and promote my own instead. Okay, so I have the collisions. Can I go there? Okay, I can, and I actually can't move, and that means the donut is generated correctly, maybe. So what if I move the player? Maybe 5. Maybe not there. Maybe 10. I'm not up. Wait, so we have this, we have the move and slide, and we should have player view position. Okay. And yeah, I can't. Maybe 1. Oh, actually, it's like proportion. But it's a bit different. Okay, so I can move, but I have to increase the coordinates by a lot, probably. Wait, can I? Maybe I can't. How can I move? No! Okay, what if I disable the collision? Like, if I go to collision, do this, now I can't. Oh, I can go there. Let's do this. Oh, that's local though. Okay. Oh, that's local, that's why. Okay, never mind. Okay, so we have this. And now we have... So no. We don't have collisions there. Wait, where are the collisions? Remote. Well, this is these are the visuals. We have the simulation group. We have the player at the end. So this is good, this is good. So let's just switch views, and we can see that we have the... Actually, it's not the player. We have the player's collision that's there. So if I move forward, am I getting closer to... Yeah, okay. Wait. So backward, I mean. Actually, was it? Was it for... Oh, wait. No, let's go forward. Forward, forward, forward. Wait. Oh, never mind. Okay, forward. So let's go there. Oh, no, it's too much. Okay. Wait. Yeah, I think there's definitely some... There's definitely some problem with this. Like, the chunks are not at the right position. Oh, that's why it looks like just a big blue block instead of a lot of triangles. Okay, it's just everything at the same place. So now we have to move like left, maybe. So if I go there. And okay, I should have the collisions now. So if I go down, yeah, okay, I have the collisions. Boop. Okay, there's just a lot of performance issues because all of the colliders are at the same place, so it's colliding with all the colliders. Okay, so there's this problem. Let me check something. So we have the... Oh, right. I get it. I understand why. It's because right now the collider is getting generated with what? Collisions, chunk, cube chunk space. Wait. Yeah, this one. Right now I'm generating it with the position of... Oh, actually it's just the cube position. Is that it? Wait, so it should actually be fine. But I guess I'm not setting the position. Yeah, I have to set the position of the thing somewhere. And I just removed it for some reason. So I might set this in when I'm creating this shape. So in the simulation group, maybe? Well, maybe not. I mean, it should be like relative to the observers. So for now, I'm going to have it here. And I generate the shape. Okay. Now this looks pretty bad. Assign chunk collider instance. I need to pass through the space so I can have a virtual function and override it potentially. I think. So I'm adding it as a child afterwards. Maybe we can, I mean, we should be able to set the position, since it's not the global position, it's just the position, we should be able to set it like there. And yeah, it's like depending on like the fact that it's a cube chunk. So I need some function. Like set position, I could have that. Like generate collider. I feel like I'm just going to have everything in the space in the end. So like this generate collider, for example, or like collider. I'm going to have I mean, I guess that can be the default implementation. Collider. Maybe just generate collider. So then we'll go in the space. We are going to have virtual void generate collider for the simulation group. I guess that's important. And for the chunk. So that means we also need to send this here. Okay. Here we go. Here we go. I'm going to copy all of this. So I can remove space. I can, well, I have to chunk collider instance. I have to include this. Like here. In collision, so there. And set simulation group. So this time it's just sim group. We're going to have, so yeah, for the position right now we can't do that. But what we can do is now we can override this function in the child. So in cube chunk space collider, for example, like this. Yeah, I was thinking, I'm just still thinking about this game, like the other game that's Ravioli told me about, like that earns so much money with like the I don't even remember how it's called, and I'm like, oh no, competition. That's fine. That's fine. I just have to make something even better. I have confidence in my skills, in my technical skills. So yeah, I can generate the collider, and what I'm gonna do is just to do super type generate collider, same group chunk. I guess I need to return this though. Well, generates collider. What is it going to be? The instance, I guess. Return this. Generates collider instance. Like spawn. It could be a spawn. But where is it? I don't know. Simulation group. There. Whoop. So now I can go to chunk space collider and wait, what? Yeah, I need to return the instance instead. And I should have the same here. This is undefined. Oh, right. Let's forward declare it. Declare. So we can actually use it. Well, use it. Have it here. And now I should, in cube chunk space collider, generate collider instance. Wait, let me think about. Make a sphere out of hexagons. So you can do that. What about what's inside? Because it should get distorted too, right? It should get like smaller and smaller. Should it? Wait. Does the inside get smaller and smaller? Impossible. Yeah, that's what I thought. Include pentagons in the hexagonal. Wait, what? Oh, right. Wait, am I? X. Oh, octagons. It's octagons, right? How you construct your sphere using octagons? Yeah, that's like a flat torus, for example. I just want to check how Planet Smith has its thing. To be announced. Oh, wait, that's flat. Oh, that's flat. Oh, that's flat. Wait. It bugged out. So that's like rotated. Yeah, okay, he has the same thing as me, probably. To some degree. Yeah. Wait, when you dig down though. Yeah, when you go down. I'm not sure at all about the underground. Like, it's showing the surface a lot, but the underground is not shown a lot. And I think it might be because he's not... Is he? I'm not sure he's handling the death. I'm not sure about this. Because like if the planet is really big, then you don't notice the distortion. But like right there, you can see that this is like one block is actually the size of the player. But is it? Yeah, like blocks are like really, really big. Baby. Planet Smith. Yeah, anyways. Thanks a lot for the reference. I'm gonna save it. Okay. What is that? Inherited member. Okay. I know. Because of this, I need the right type. And now I can get the instance. Has no member. Yep. I can call this. Inherited member is not allowed. Let me check. Is it private or something? Generate collider instance. It should be good. Oh, right. Like this. Good, good, good. And now I should have get chunk. So I guess, yeah, I don't have the coordinates and things, but that's why I can get my helpers. I actually already have it here. I can check casts. So that's going to be cube chunk. Shape. Wait, that's the shape though. Let me think a little. So the chunk coordinates. Yeah, that's about the, wait. That's the big problem. Isn't it? Chords. Yeah, I don't have it here. Chords. Get chunk chords. So cube chunk. Oh right, that's about yeah, okay, never mind, I get it. So I actually just want cube chunk. So cube chunk, and the instance is going to be, yeah, wait, let me Planet Smith. Yeah, I'm really curious about this game, I guess. Engine. Oh, that's why. Voxel physics engine. Unique custom voxel physics engine. Oof. Which builds fully spherical explorable planets rather than the endless flat plains. Engine had a completely custom voxel engine from scratch. Oh my god. Players can walk completely around the planet with procedural generation. Seamless space travel. Custom physics solve. Yeah, so voxel physics. Custom physics solve clipping and coordinate wrap issues associated. So I don't think they're using large world coordinates. Well, like they can't make worlds that big because they're going to hit the flat precision issue. And they won't have like all the Not including things I have, probably.
5 years ago, I started building PlanetSmith. At its core, it's a sandbox survival RPG where you explore fully spherical voxel planets, build anything you can imagine,
Tech challenge,
and eventually
custom voxel physics engine
to explore the entire solar system. Inside, optimize the game. 12 bits stored the
Wait, you can play it on...
and the remaining 4 bits stored block state. Things like rotation or color were already showing their age. In fact, the old meshing system was one of the biggest causes of lag spikes. Extreme, even in entire alien worlds. Our left-hand fun feature, 16,000 compared to the radius of the planet.
Wait, it's... Yes! It's using Unity! That means it sucks! Just kidding! Yeah, I don't like Unity. Okay, okay. Anyways. So we have this. We have the chunk, I guess. So this is a cube chunk. And we're going to have the instance. And is it good? Yeah, a chunk collider instance. Okay, I have to include it. Modules, voxel, collisions. Chunk collider instance. Wait, I have all of this that I'm not using. No, I am using those. Well, some of those, not all. But yeah, I can set the position now. And now it should be a lot better, maybe? Is it? Generates collider instance. What about the parent? Because it's a generate, right? So maybe I don't want to add the child here. Right? I don't really know. Let's just go in generates collider instance. There. And I'm going to add the child after that. Like this. I think that might be good. That way we ensure that it is starting at a different position. So there is going to be like no computations. I mean, I think it's fine if I add the child before, but I'm still going to do this. Save, okay. I don't really know what I saved, but why not? But yeah, I think one of the problems with the game is PlanetSmith is octagons. Octagons suck. Well, for me. I mean, it seems like you can still construct things. But it's like not even, it's not an octagon, it's like, yeah, the voxel type is kind of. What is that? What is that? Earth-like worlds. I need something incredibly beautiful to beat this. Let's return, yeah. Let's return this. So yeah, I intend on doing a lot of, you know, a lot of optimizations, of course, but also what? A lot of good rendering things. Function must return a value. Oh, right. Oh, right. Check. Ah, right. Okay. Maybe Maybe. So if it fails, there's this. And I mean, I guess I can just add a V. There's like return value. Return value. And this is gonna go here. Error, fail, null, V. With like the return value. That's going to be... This is not going to be used. And yeah, this is just going to go there. And I can just do this. Oh yeah, it needs a return value though. I guess it's gonna be null. And I guess in the parent though, wait a second. In the parent I have to ensure this is good. Maybe not the parent, but the simulation group. I have the instance and I have to check if this is null or not. I'm doing a lot of checks, but that's fine. Because I can remove them from the release build, potentially. For optimization. And yeah, that's why I'm kind of glad he's using C# because I can get some performance, some good performance, good things. Well, I can build it performance-wise. And if. Is it? Unexpected and if. So define. Oh. Wait, no, that's just a define. If not def, define. And if, so at the end. And then we have if def this. And we have... Oh, right, this. This is it. Okay, yeah. Should be like this. Is it? If. Should be an end if. Wait. No, okay. This should be here. And we have if this. Should be good. No, maybe not. If def and if. Okay, it seems to be fine. I don't know what the problem is. Define. Oh, no, I know. No, I don't actually. Yeah, it should be good. Why do you have a problem with me? Linking program. Yeah, it's good. It's good. It's good. Yeah, I'm really going to continue checking this again and again. Yeah, what's the problem with this? Oh, they actually made a game with octagons. Well, with that kind of thing, I guess. Planet Smith. Whoa, they started like a long time ago. Website, YouTube. Maybe I need a website. Oh. And the mail list. That's neat. Yeah, what about this? My god, we have so many subscribers. X versus cubes. Which actually makes a better planet. Yeah, which one makes a planet? Actually, I know what this is. It's going to be... Yeah, I actually know. Kind of, maybe. Creating the ultimate procedural Generation tools. My god. 5 years building. So the upload frequency. World gen rebuilt. 1 line of code. How you increase the frame rate. Improved multi-threading. No curvature. Does the donut have 0 curvature? Oh my god, they actually did what I did. They actually did what I did. Behind the scenes. Wait, they actually... They actually already had a lot of their things like 2 years ago. But it took them like 3 years to make this. So... my god. Kickstarter.
If you want to be part
Already?
of the Planetsmith journey, you still can.
Oh my god.
We have some great Smith
Cube planets.
squares
Yeah?
or hexagons,
Yeah.
which
So...
means all the distortion needed to warp a flat grid into a sphere
yeah?
that's spread across those 8 points.
Yeah?
But with hexagons,
Wait.
you have
That's
to
not-
use a use
Yeah.
squares. You have to use a cube as the base shape.
Yeah?
A cube has 8 corners,
Yeah?
which means all the distortion needed to warp a flat grid into a sphere
Yeah, but
spread across those 8 points.
it's actually not a problem.
But with hexagons,
Because of
we can
distortions,
use an
local distortions.
icosahedron as the base shape, placing 1 pentagon at each of the 12 corners.
So it's flat! So they have a flat planet?
This means the
No.
distortion is spread across
No, no,
12
no.
points
No, they distort.
instead of
Yeah,
8,
they distort.
making it much less noticeable.
Yeah, much less notice. Okay,
And
okay, I can
There's
understand
another
that.
advantage. Squares have perfect right angles,
Yeah?
so even small distortions
Oh,
are
squares.
really obvious.
Yeah.
Hexagons, they hide distortion.
Yeah, they hide, but
back.
that means it's less
In fact,
good for the player.
I
Donut planets.
bend the world around the player, keeping everything as perfect cubes where the player is. Games like Eco actually do this, and it works.
Okay.
But there's a problem.
Wait, what? Echo?
Use shaders to bend the world around the
Use
player,
shaders. You don't have to
keeping
use shaders for that.
everything as perfect cubes where the player is.
What do you mean?
Games like Eco actually do this,
Echo
and it works.
game. Donut?
But there's a problem. This trick has some compromises that won't work for Planetsmith. Let me show you.
Okay.
At first, everything looks fine.
So they do have donuts in
Run
Planet
around the
Smith?
equator, no issues.
Yeah?
Go north, cross the pole, still looks okay.
Yeah?
But watch closely.
If you go down? No.
We cross the North Pole and end up back where we started
Yeah, that's the point.
without ever going across the South Pole. That's not
What?
how planets work.
Wait, what?
We can fix that.
Yeah, that's not how that's not how planets work. I know.
Mapping. Now the poles
Wait.
behave correctly, but the equator breaks instead. You are now locked to exploring only one half of the world unless you cross a pole.
I mean, he just said it's a donut, right? So I mean, it's a donut. That's
But
normal that
maybe
it's not a planet.
acceptable. But now watch this. I run to the North Pole, turn 90 degrees, and continue running. I'm now stuck running in a loop forever around the North Pole. Close up, I have to
Yes?
say, this doesn't look
Wait.
too bad. Sure, you have some weird quirks, but
Wait.
it still feels Smith from a distance. Space travel.
For
So
space
what
travel.
does this look like from a distance? Orbiting the planet
Wait.
around the...
So it's a donut.
No issues.
Why is he
On
talking about
screen
donuts?
Right now. Another super common suggestion is...
Oh, that's
why
another
not
suggestion.
fake the curvature? Use shaders to bend the world around
Oh.
the player, keeping
Oh.
everything as perfect cubes.
That's not really the donut. No,
Looks
he's
like
not talking about the donut.
actually do this, and it works.
But
there's a problem. This trick has some compromises that won't work for PlanetSmith.
yeah, that's not
It used
really.
to grow and shrink, which looks very strange. All of a sudden, the North Pole expands into a ring that circles the... But it isn't. It's actually
No, it's a donut.
full
Yeah, it's
of
fine to
inner
have a
stuff
donut.
to make it look like a sphere. When I expand it, everything suddenly makes sense. One half of the planet
Yep.
is the outside of the donut.
And yeah, this is fine.
and the
This is
other
good.
half
Okay, so we've actually thought
with
about it already.
features like being stuck
Um,
in a polar loop.
Polar loop.
Navigation, importantly,
Did you do?
grows
This is
and
fine.
shrinks depending on how you orbit it.
Well,
That's not the experience I want. Because, well, visually, from ground level, it breaks down when planets are viewed from space, as the surface of the planet grows and shrinks depending on how you orbit it.
I mean,
That's
okay.
best for planets. What about hexagons
Hexagons.
versus squares for building?
Yeah, what about this
Are
for building?
hexagons the bestagons? Immediately, most
The
people say
bestagons.
no.
Yeah,
Cubic
right.
blocks win. You can make nice and easy right angle.
Mhm.
Before I offend all the bees watching this video, let's go on to the advantages of you
Hexagons.
can build in. Plus 3 diagonals for a total
Yeah.
of 6 directions. Shapes like circles much easier. But I can hear you in the
Okay.
comments already. I want a square house. Well, luckily you can.
Luckily, you
just
can.
need to build on a diagonal. Take
Oh,
a
that
look
makes
at
sense.
This house, for example.
Oh, that makes sense.
It
I
looks
bet
quite
it's
square, but it's made out of
yeah.
what games they have played, like Minecraft use. Hex. Saturn's
No, cubes are the
poles.
bestagons.
You can build some incredible things with them. It
I
just
mean,
takes
you
a
can also
fresh
have
way
both.
of thinking. To me, feel very core
Really?
to the truth of the universe. Something the Pythagoreans back in ancient Greece believed. If you want,
Yeah, you can just have both. I'm just going to copy the link. Feel free to check it out too. But yeah, that's a pretty. I'm going to put it in my references actually. Where is it? Standard, no. Voxel game. Okay. So yeah, I'm gonna have a references. I'm gonna have this with the link to the game. Because this seems pretty important. Visuals. Yeah, visuals. I had my video that was pretty nice looking. My God. Okay. And I mean, I'm just gonna polish this with time. Let's run this and let's see if it's actually working now. So it's gonna take some time to generate the colliders, probably, again. What if well, actually, let's keep it, I guess. Let's generate... Oh, it's actually faster than before. Like, I guess, okay, never mind, it's still generating. Why is it taking so long? I mean, I have my idea, I guess, but yeah. I can also optimize it by not requiring the colliders right away. Can I maybe add a delta time? Like a delay between the generate... I mean, technically I should be able to generate... I mean... Well, I mean, that's kind of the goal, right? To generate colliders by priority, by how close they are to the player. Okay, so we have... Okay, so now it's good. Now we actually have the colliders for the chunks. Should I merge? Because I have a lot of triangles, right? Should I merge the triangles? Is it gonna be faster if I do that? I don't know. I think it's because I'm iterating over every chunk again and again. Okay, so anyways, I have this. Let's switch to here. I'm gonna go up. And now I have some collision, and it's like kind of optimized. I can go up, I can't go down past the donut. And yeah, this is just fine. Do I want a rotation on the donut? That would... Oh, wait. Because I was thinking there's no light here. But what if I have instead in the middle some kind of sun? So that means there's going to be light. And what I can do is have the donut rotate. Like from the outside to the inside, like this. So not like the whole donut as a single shape rotate at once, but like, have the outside turn towards the inside. That would be crazy though, I don't know how I would do that. But I have colliders. I can sprint. I mean, that means I could get gravity too. Let me... So right now I have this. Let me check the player. So here, player position. This. I'm just gonna copy this and apply it to here so that I'm always at the surface. And with the colliders below. And yeah, I do want some gravity though. And I do want the generation to generate, not to, well, to generate one by one, not to generate all at once. So right now this generate colliders is kind of working. We have the new simulation group. Okay, so I need the observer. And simulation group gets observer. Or maybe not there though. I guess it's in the space. In the cube chunk space actually. I have this little update colliders. Okay. And yeah, I can generate collider. So this is cube chunk collider. This is cube chunk space. Let me think about it a little. So if it is inside, if the player is inside the chunk, I want to generate it right away. So I'm gonna... I should have the space. Generates... No. Wait, that's a space. Is it? Chunk space collider. Oh yeah, okay, that's this function. So I should be able to generate collider instance. That's what I actually want. I'm gonna generate the instance. And we have the simulation group. And we also have the chunk. Instance. Let me just check this again. So yeah, I had to add it as a child. I mean, I guess I can set the position though now. Yeah, wait. Yeah, I can actually set it here instead of the parent. Because this one is just generating stuff, right? Cube chunk space collider. So yeah, it depends on the sim group too. Yeah, but it has to be a very specific instance, though. Because I can have multiple instances. So wait, what I was trying to do well is not actually working. Well, I mean, that's understandable. Okay. Update colliders. What is this doing? So I get the chunks if there is no collider. So this is trying to generate. Well, is that going to be? Wait, what is that actually? Is that a shape? This. Okay, this is the shape. So I'm going to spawn not the chunk. I'm going to spawn the shape. Yeah, this is about the shape. That's not really what I want to do, is it? Because I want to spawn the shape when needed, and then I want to spawn the instances. So I have to go instances first, so spawn instances depending on needs, and spawn shape if doesn't have. That's what I need to do. Yeah, okay. What am I gonna do? I'm going to take a very small bathroom break. Be right back. Okay, sorry about this. I'm back. Phew. Okay, so let's continue our little collisions, shall we? So spawn instances depending on needs. Yeah, that's actually what I need to do. I need to spawn that depending on the observers. So these are the observers, and I can spawn a chunk. So, okay, yeah, for each observer. So that's kind of what I was doing, actually. For each chunk. That's not really what I want, because I can optimize the... I can optimize this. I'm just going to comment all of this because this is wrong. And go there. And have the observers. Wait, what is that? Oh, right. Right. So I have this. Here we go. Observers is... Wait, I'm doing a copy. Ew! I mean, I'm gonna remove it anyways. But yeah. Let's loop. Observer. And for all observers, I need... So basically it's a point in the graph, right? So I should have observer. There. Space observer. And it has to be a cube chunk space. Yeah, cube chunk space. So I can basically do checked casts. Right, because this is a void. This cube observer and observer. So we have this observer that has a lot of, well, that has a few coordinates, a few extra coordinates and information. We have the coordinates in the cube chunk space, which is pretty good. Inaccessible. Right. Yeah, I can just use this. And from this, I can actually optimize the finding, because I should have the space somewhere. Space. Okay. Wait, where was that? There. So cube, well actually it's the same but without the observer thing, probably. Then we have the space that we want to convert into a cube space. And this doesn't exist. Cube chunk space. Yeah, it should exist, so let's include it. Chunk space. Yeah, instead let's include cube chunk space. There. Here we go. Is inaccessible. So it's like gets space. That's fine. That's good with me. Okay. Get cube chunk coordinates. Yeah. And I should be able to... Basically right now I have the amount of cubes in total. Okay, so I mean we also have the... I guess it's about the torus. Torus chunk space. So we have the radius. Is it? Let me think. Cube chunk space, the amount of cubes. Yeah, I have to check this. What do I have? So yeah, this is a float. What happens if I do like this? I'm not sure how it's going to look like. And we have... Oh wait, I was gonna say collisions are going to take a long time. But no. Yeah, why am I even using this? Small and big. Wait. Oh right, it's the distortion. Oh, so it actually doesn't matter. It actually doesn't matter, right? Yeah, it doesn't matter. It's actually just the number of cubes that matters. Yeah, okay, this is fine. Okay, so I can keep it here. And optimize this. So I have the cube space. I have the NV cubes. Get NV cubes even. So it's like a const vector 3i. NV cubes. And I'm going to modulo this, maybe? Am I? Gets cube chunk coordinates. Wait, yeah. Big cubes. Cube chunk coordinates. Okay. I just have to be careful about this. So I'm gonna... So I have the coordinates. Cards. Which is this. And I'm gonna... Oh, wait, I want to do... Wait, what do I want to do? I want to spawn the chunks around, right? Oh, what are you making? Hey, hey, Rehan, how are you? Sorry, I didn't see your comment. Are you still here? I'm making some kind of Minecraft game, you could say. I'm making a donut right now. I have a donut. I have a ring where you can... Wait, let me actually go. Well, let me go there. Wait, oh, I disabled the colliders. But yeah, you can basically, you know, break things, break the blocks. And it's like a ring shape. I guess that for now that's what we have. Yeah. And right now what I'm doing is I'm trying to spawn the colliders in a way that doesn't make me freeze at the beginning. Because I'm going to have to start the game a lot of times too, so this is pretty good if I handle that now. And I have to generate them for like the whole donut. So coordinates. Wait, number of cubes. So we have the coordinates. Update colliders. Maybe I can just generate those in an area around. Like, for now, let's just have I equals 0. I is less than... Actually... Wait. Max generation distance. Yeah. Maybe something like this. I is less than this, and I plus plus. Maybe we're going to have like some priority queue or something. And so this is going to be J and this is going to be K actually. Well, I mean, I guess it doesn't really matter. But yeah, K, K. Oh no, I was gonna say it. It's the K cake. Okay. Okay, here we go. So we have all of this. Okay, for now we don't have a priority though, but we can spawn and despawn chunks, which is pretty good. So we have observer cards, and we are going to have, wait, that's in cubes. So that's the size in distance in cubes. Is it? In chunks. Let's say this is a distance. In chunks. So then we can... Oh, some chunks are going to be very small though. So I'm not sure about this. Right. Right, I can't do that because some chunks are not the same size as the others. Oh, that sucks. That kind of sucks. Does it? It should actually be fine if I handle this with care. So I have the cube chunk space, I have those, and I can generate all chunks, right? As you can see. So default chunk. Oh, this is the default chunk size. Yeah, let's have this here. This is gonna be useful. And this is the total size. Okay, this is like pretty useful. Yeah, what's the amount of cubes anyways right now? Okay, this is what I mean a lot, right? 155, 25, 2325. Ah, something like this. Okay. So then the amount of cubes. You know what? I feel like pushing now, actually. I feel like pushing now. Yeah, I'm gonna push now. I'm just gonna generate colliders. And we have this. So 10 chunks, well, colliders generated, but all at once and static. And I'm just going to use the same message for this one. Hit add. We're going to boop. Probably. Classes added. Yeah. Let's have this. And now let's finish what we started to do. Right? So we have the observer coordinates and we have so I have the position. Let me think about it. Cube chunk coordinates. So that should always be I mean, I guess it depends on the space, right? Space observer. I mean, yeah, there's this. So I have to ensure this is inside. I mean, I guess I can have like a cast, like air, true, false, fail, condition, message, editor message. And basically this, I guess this is gonna be a long condition, but this should be less than this. And I wonder if like there's already a function for that. Can I just do this? If it's equal. Yeah, what if it's not? I check if it's less. And if this is less, then this is good. If it's equal, we check if this is less. Okay, this should be good then. And I also want to check if this is higher or equal to 0. So it's a free I. This. I should have like a static thing anyways. And the 0 message is going to be observer coordinates is not inside the chunk. Inside the space. Is outside of the space. Oop. Yeah, that's not. It was my alarm to stream at 3 a.m. Okay, we have the observer coordinates that should be valid. And I'm going to should it, actually. I mean, I guess it should. Let me think for a bit. So it's about colliders, right? Yeah, but if this is valid, though. Wait a second. If I have that, that means I won't be able to generate colliders at the right place, right? Like I am gonna have to teleport the player, but I don't want to teleport the player right now. Not right now. So what am I gonna do? So all the observer coordinates are always going to be inside the space. Is it a big deal if like the parent moves but not the player? I mean, there's going to be a problem anyways. There's definitely going to be a problem with this. I mean, we are in the collision thing, right? So maybe I need like the world space coordinates for this, really? Do I? No, it just needs a... Wait. Yeah, okay, this is... Okay, so I need the world space for the collision player, for the collision of the player, which is a bit different. Player collision position. Hmm. Yeah, in any case, that shouldn't really be true. That should not really be true. Cube chunk coordinates. Yeah, that's a simulation, but yeah, that's in core though. That's in core. Maybe I need something in the collider section. Like some additional data for those. Cube chunk coordinates. Because this should always be... Should it? Wait a second. Okay, let's just have vector free collision position. Well, collision. Yeah. That's not clean, but that's fine. Collision position. Maybe I. Collision. This. I'm not sure, okay. This is basically unclamped. And yeah, I should have another class for this. This is fine. So instead I have vector free. Well, I kind of have what I had before. So this. But instead I'm just going to have collision this. And now that I have the cores that are not clamped, I should be able to loop around. So like chunk cards equal this plus vector pi ij k. Okay, wait. That sounds bad. Wait, y is up though. ikj. I'm not sure about this. Let's just have this for now. Okay, let's have this. Let's have this. And I'm gonna try to spawn it. So if the player is in, so like if everything is 0 actually, I'm gonna try to spawn it instantly. Am I? But yeah, I have the chunk coordinates, but I don't have the chunk yet. How do I get this? If this is... cube chunk. So yeah, I have all of my chunks there. That's kind of the problem. So the goal is... Wait, I can optimize it in different ways. I can optimize this in different ways. Maybe I don't want to optimize actually for now. Should I? Wait. Wait. Yeah, instead of looping like that... Do I really want to loop like this? I don't think I do. So... Okay, I have different possibilities to retrieve the chunk. So the goal is to retrieve a chunk. Okay? So I can loop through chunk coordinates and get chunks close enough. So with so basically it's OIJK and gets the chunks close enough. So that can be ON, like performance wise. That can be ON or O1, depending on if I have a hash table or not, a hash map or not. Or I can loop through all the chunks and check if this is inside the player, like close enough. I mean, this is the same thing. So I'm probably gonna get the coordinates and get the chunk that corresponds to that. So for that, I should have... where was it? It's about the space, was it? Chunk. How am I getting the chunk from the space? Wait. Yeah, there. So I get the space. And instead of looping through chunks, what I'm going to do is find chunk. Because wait, I know what kind of space it is, right? So that means I can... Yeah, I guess I already have it here. And I'm going to move this out, actually. So this is a cube space. And that means I can find the chunk in an optimized way from the coordinates of the chunk using a hash map. So now I can get there, please. Vector 3i, find a chunk. So chunks there. Yeah, I have that. Yeah, okay. Yeah, should be good. And for now, we can have something pretty... Wait. Pretty simple, maybe? But... It's... chunk coordinates. We're going to return a chunk. Or like maybe an index. What do you think about this? Maybe an index because we might want to remove the chunk from the array and remove it by swapping with the last one. And that's going to be very optimized. So int 32. I mean, I can always... I was gonna say... Never mind. Index. Or like find chunk index. Then we have the find chunk, I guess, if we don't need the index. so we get the chunk directly. But this one is actually just going to be return chunks, find chunk index. So this is just like a helper, basically. So that's why it's here, because that way it can be inlined if it's in the header file. So it can be more performant. And it's expecting something because it didn't find chunk, because this hasn't been defined. Has it? Actually it has, because it's in the array here. I'm just gonna move the forward declaration on top. Same for this one. Okay. Should be good. What about here though? Vector 3i, maybe this one is... It should be defined though. Yeah, it's defined because this compiled normally. And this one is not found, so this is probably the reason why. Cool. So we're gonna do this. Okay, yeah, this is compiling file. This is compiling fine. So now to find the right one, I'm going to have my map, maybe, to dictionary. Is it? So this is not templated though. What if I do this? May not have template argument. Oh, is this maybe a hash map that I want? Oh yeah, good. They have a hash map implementation. Invalid type for a bit field. What? Key value. What do you mean bit field? Wait, what? Invalid type for a bit field. I can't have this. What? Wait, what? Go to CPP hash map. Go to dictionary. I don't. Go to hash map. So string to int. Does not need to expose the container directly. This is custom iterators. So it's like this. And another map. For standard C++ flow. I guess there is this, but this is not very optimized, right? Features a familiar API. Wait, does it? No, yeah, that's from the STD. And it's strictly internal logic. So what's the difference with this? To play race with statically typed keys and values, giving it much less overhead than dictionary. Yeah, I know. And its erase method behaves slightly differently than the C++. It's just STL. Okay, so basically, what if I have vector 3i instead? Invalid type, okay. What if I have chunks? Yeah. So chunk pulse to chunk. This is gonna be the name, and oh no, it's just not included. I just have to include it. That's why there's a problem. So core templates hash map. Okay. Core templates hash map. Hash set. Do I want a hash set? I mean, technically, it's only... It should be the same, right? We do hash map versus hash set. Hash set only stores unique individual values to track existence. I mean, this is technically the same though, right? Low level. Yeah. Wrapper optimized over a hash table. Oh, it's a wrapper? Wait, a hash set is just a... Wait, what? Wait, let me get the hash set. I mean, that makes sense because that way you don't have to record the same thing. But at the same time, I don't know. Hash map. Hash map, hash are default. No, it's reusing comparators and stuff, but it's a different type. Okay. Do I really want this though? I guess I do, I guess that's fine. So I have the hash map. Wait, actually chunk. Never mind, chunks already have a position. Right, wait. Well, actually it's a cube chunk, right? It's a cube chunk. So I have all of this and I have the chunk coordinates. So that should be really a hash set. Yeah. Should be this. And I should have... So I have the hasher, which should be good. It's just... Actually, what is it? Wait, never mind. Wait a second. No, that's not from one value to another. Yeah, I need the position. Yeah, never mind. I need this. This is a hash map. Forget what I was saying. Okay. And whenever I generate the chunk, so there, I push back, I set the chunk coordinates. So I do a lot of things. I can set it. Okay, there's no set actually here. There's just chunk equal, or like chords. Okay, it's not a multi-map. It's not a multi-map. That's the difference. So I can assign the chunk to those coordinates, which should be good. Wait, I guess it's... I think I'm gonna have problems when I'm going to destroy those, because I'm checking with null, but if I remember correctly, you're not supposed to check with null. You're supposed to check with something else. I don't remember. But yeah. So now I have the coordinates, and I should be able to find the chunk index. Oh yeah, that's the index though. I don't want the cube chunk directly, I want the index. So I have all of this, I have the pushback. So I'm just going to do chunks dot size. And this is going to be the int, or more specifically, what is that returning? The size. So I'm going to use the size too. Shit. What is that? Code data. Vector, I guess. Like, I guess technically I can have deck type chunks. And this is size. Yeah, should be good. So now I have this. Yeah, this is pretty bad. It's fine. Chunk pose to chunk index. I can technically, if I have a hierarchical, if I have hierarchical chunks, I could compute the index a bit faster, but yeah, I guess that's it. And then we can return find a chunk index. Do I want an int32? I may not. Yeah, this is probably not going to be enough. Let's have in the parent chunk index maybe. Chunk index equal this. And that way in the child I can just do this chunk index, then I find the index there. Yeah. Then I can do a get from chunk calls. And this is supposed to return an index though. A call. Wait, what? Call of an object of a class type without appropriate operator or conversion functions to pointer to function. Well, what? Chunk plus to. Wait, what are you talking about? Get. What? Can I just have it have this here? I can. So what's the difference between expected something? I don't really get it, but I'm gonna restart Godot and see what the error is, because I don't get it. Call of an object of a class. Yeah, I think that's invalid. That's an obsolete error. That's a bit obsolete. Undeclared identifier. Yep. And cube chunk space. What? Find. Wait, here? Oh, there. Okay. Like this. I do want to do the add child after that though, and then I generate maybe. What about? Yeah, so I actually don't really need this. Well, this. Well, I mean, what I wanted to say is the size isn't actually going to matter much, the size of the chunk, because we are only getting it based on the coordinates, right, of the chunk. So as long as it has a distinct coordinates, which is obviously the case, then there shouldn't be any problem. And set chunk chords. Oh, wait, this is actually a bit tricky, because this is not this is position in blocks, and yeah, so this is a bit ambiguous. This is ambiguous. Block, well, cube chunk chords. Maybe, yeah. Chunk chords, cube chunk chords. Well, chunk chords in cubes. Is it? I mean, that should be good. Even if they have a different size, they should have like coordinates in this case, in this specific case. So we have this. I'm afraid of a lot of things. Let's just copy this for now. In blocks. blocks. Oh, in cubes. My bad. I could technically make a function instead of, you know, storing it for like, well, storing it, I guess. I mean, yeah, technically I can totally do that. So I guess I'm just going to remove this. Chunk cards. Yeah, I can remove this. I can keep the getter. And this getter is going to be used sometimes. So like here, like, I mean, yeah, that's going to be a problem. Cube chunk. This one is fine. I mean, I guess that was the only place it was actually called. So this is good. This is good, this is good. So yeah, this one is going to be this modulo, maybe this, and this should be fine, because even if the size is different, let me, why am I actually generating it? Generate, wait, wait a second. Cube chunk. What about, wait. Oh. Oh wait, that's the wrong place. Wait a second. Wait a second. This is kind of important. Chunk cards in cubes. Technically it depends, right? Technically it depends. I don't actually need this. And I can have like even bigger worlds if I don't have this. So chunk cards in cubes. I actually don't need this. I can actually keep this. Wait, 2 seconds. What? Chunk cards. Position in blocks. So it's actually not going to be the position in blocks anymore. I don't need this. Probably. Do I? No. I should not. Chunk card. Okay, this should be defined now. And this should be good. And the only thing is I have the sets chunk coordinates here. And this should be divided by, well, modulo. Wait, modulo. Wait a second. So I have this. I reset to 0. I guess I'm doing some micro optimization. Okay. And if this is less, I continue. So this is always going to be divided by NB cubes, well, minus chords. Wait, minus. Because I'm going, wait, what? The size. Oh, right, never mind. Yeah, this is a minimum. So we have the size of the chunk, which shouldn't actually matter. And we have the coordinates, where I'm doing plus equal the size of the chunk here. But I actually don't really need this. Well, I have the chunk chords, and I have the thing in cubes. So chords in cubes. Wait. NB cubes. So yeah, that's the total amount of cubes. Yeah, let's have two chords in cubes. And we have chunk chords, which starts at 0, 0, 0. And I'm actually not sure about... Am I sure? Well, it's generate all chunks, so it's a bit special. I won't actually do that in practice in the end, so this is fine. And the chunk coordinates are going to be... What are they going to be? Yeah, I guess technically I don't want the coordinates. Oh, wait. Technically I don't want the amount of cubes in total. I want the amount of chunks and the size per chunk, with the last one being an exception, probably. Yeah, that way I can have even bigger worlds, like times 32, or times the size of the chunk, which would be like a lot. I mean, I'm not really... Yeah, I guess that's not really the issue much though. It should be pretty big. I'm like thinking a lot about it, but it's actually it's actually not very important. So current chunk size, yeah, okay. Chunk coordinates. So this is going to be 1, 1, and 1. And then we have set coordinates there. And we have chunk pairs, well, chunk chords actually. Chunk chords to chunk index. There. We have this. Find chunk index. Yeah, I guess I can just have it here. And I can remove this. This is probably why I had an error before, or maybe not. Identifier isn't defined. What do you mean? It's just there. Okay. And I guess that's mostly it. Let me just check if I have a get. Well, for the chunk, if I have a get chunk chord. I just have the definitions and exposition to GDScript. So that should be fine, except if I'm using that in GDScript, but yeah, should be fine. So now that I have all of this, let me actually NB cubes to do sets with NV chunks, well, replace by NV chunks, chunk size, and last chunks size, maybe? Like remainder chunk size, maybe something like this. For bigger coordinates. Yeah. Actually, it might. Actually, it might. You know, it's gonna take. Yeah, I mean, maybe not. Maybe not. Because it will be even more memory efficient if I just increase the size of the int with a big int or something, I don't know. So anyway, we have this. We have this, we have the coordinates, we have the collider, we have get chunk chords, so this time it's the real one. Wait a second. Okay, it's actually a bit different. Times get block size. Oh, so that's in the walls. Right. Yeah, wait, it's for the collider though. It's for the collider instance. This is complicated. It's actually a bit complicated. I mean, maybe not actually. Oh, maybe not. Block size. Yeah, never mind, because it doesn't matter the final size. Because it's just like times defaults. Defaults, or like chunk size. Can I get it? Like I should have... Oh wait, actually... I guess it's not here. I guess it's in the space. So I should have the space from the chunk. So chunk get chunk space, cube chunk space, and I can just do get defaults, or like something default chunk size. Yeah, this. Okay, and it should be good. It should be good, technically. And like relatively, I was gonna say optimized, but yeah, it should be fine. Should be fine. So then we have the chunk coordinates, and then we can find the actual chunk coordinates, right? With like, well, this, I guess. Wait, J, let me put J. That pains me a little that it's looking like this, but yeah, let's JK. It pains me a bit less. So we have this, we have the find chunk, we have the chunk. Then I guess we want to check if it has a collision. Do you have a collision, my chunk? Get collider. If it is null, then we do something about it, because we want to assign it. So in this case, we're going to spawn the thing right away. I guess if it's such... Wait. Right. I mean, I have the coordinates right away, right? So I can always find the chunk and do something about it right away. Like I can just test here, but anyways. So this is to generate it instantly. So if it doesn't have a collider and I equal 0 and j equals 0 and k equals 0, that means it's at the player's location or something like that. Or maybe, do I really want this? Maybe I want to move it stop, but that's fine. Yeah, maybe I want to check the free chunks around. Right, hey Danny. Okay. Okay, so if it's this, then I create and I add child. I return. Okay, why not? If it's a problem. And I mean, I don't want to return afterwards here. But yeah, okay, so I spawn directly. Or if it's absolute, I guess absolute is fine. Absolute. To less or equal to 1. Less or equal to 1. And same here. So we generate the collisions around. And if it's not, generates collisions immediately if too close, I guess. Maybe this is fine. And else we can create it with some delay. So with the dispatch, like here, like this. So we're still going to create the instance though. It's just going to take some time, I guess. So we can test it. And wait, generate. What about the dispatch? Wait, oh, it's there. That position. Wait a second. Generate collider instance. Oh, right. Oh, right. Right. So I guess right now, if this is null, yeah, I don't want to generate the instance though. That's what I was doing. Yep. So I'm gonna find the collider. Wait. Yeah, it's creating the shape right now, which is not what I want. So I have the chunk though. I want different priorities and async or not depending on the case. So generate collider instance. Let me. Am I wait? Yeah, I have this. I have this a lot actually. Yeah, let me remove this because this is a bit obsolete. This is a bit bad. So I have this one there. I have the override, yeah. I have the CPP, the implementation, the default implementation. That instantiates the shape actually, so it's kind of bad. And I have here when I generate all the colliders. So generate collider instance. I'm going to do something in between. I'm going to get the shape. Like find chunk shape, collision shape, I guess. Yeah, chunk shape, this is fine. And then if this is null, I guess I shouldn't do that, but yeah. If this is null, I generate it. So that was spawn chunk shape and generate shape. So in simulation group, yeah, okay, this is fine. And this is a function from chunk space collider. So space, yeah. So spawn, I can spawn, and I can generate immediately. I'm just gonna specify that this is sync. Can take time. Well, slow. And now the find chunk shape. Yeah, for this one actually, this is pretty simple. This is just, let me. Wait a second. Yeah, this is not how it should be. Shape and, well, chunk shape. I don't have this. I should have it. Collider. Yeah, this is actually the shape. So shape. I mean, this is protected, so it should be fine. In shape. Yeah, let me change this while I have when I still have the time. Set. So now I can change this shape. It's shape. It's shape. If this is null, then I can wait a second. Yeah, so it is null. It is already null. So in this case, I can generate like directly, right? Because it's already null. So I don't need to find or anything. So I spawn it. And I generate it. And then I generate collider instance with the shape. So chunk shape should actually have the chunk inside. So that should be good. That should be good. I can replace this generate collider instance. This is virtual though. And that makes sense because I'm overriding it in the child. Spawn chunk shape. I already have it though. So now I can remove. I can put shape. So I set the simulation group, I assign the shape. Like I set shape, I should just set the shape. Yeah, let's rename this. Like assign, what am I doing in assign again? And I guess I initialize. Connect. I add a child. Yeah, no, never mind. Okay, yeah, this is fine. Cramp? Okay, this is good. This is fine. No, it's not. Yeah, this is fine. Let's say this is fine for now. Let's not modify it too much. Attends. So we have the shape. And now we have the collider. We have the generate collider instance. So it was here. It was here. This is a cube chunk, a chunk shape. So yeah, I guess I can get this. I guess I'm actually using it. So let's do this. Cube. Chunk. Oh, my bad. Wrong one. It's shape. Gets chunk. And then we have chunk gets chunk space. So I guess cube chunk in this case. Chunk is undefined. Chunk. So generate collider instance. So this is a collider instance. Wait, no, that's not what I want. Shape. Wait, I'm generating the shape. Oh, no, I'm sending the shape. Yeah, never mind, I'm calling the parent function. So this is creating the instance with the shape I'm giving. Okay, should be good. So now I check if it already has a shape or not. If it doesn't, I'm going to create it. The goal is to create it. And not create the instance here. This is gonna be afterwards. It's gonna be like there. Oh, is it? Wait. Yeah, so this is about the shape. I don't want the shape right now. I want to create the instance. And it should have like multiple instances. And it's about the simulation group. And I should have the instances there. Do I have it? Do I have them here instead? So I have the instance, and I just return. Add the child. Wait, what? Here? Nope. Here. And that's not really what I want to do anyways. Generate collider instance. This should actually be a function from the group, right? Because I already have... Wait. Do I want to be able to override this function? Obviously I did it, so yes. Okay. So I send this. Yeah, so the positions are going to be a bit wrong actually. Well, collision space, collision coordinates, collision chunk coordinates. Collision cube chunk coordinates. Okay. So this is in blocks, I guess. Oh. I mean, this is just going to be this, really. Yeah. Collision sim coordinates, let's say. Collision sim coords. Okay. So I'm gonna get the coordinates. That is, I mean, I guess I can... It doesn't have to stay a vector free. This is fine. So then I do a plus. I have the coordinates of the chunk. Wait, what? No, it's not like that. Wait, no, it's not. No, it's not. Wait, it's not like that, right? I have to get the cube space divided by cube space NB cubes, and then I divide again by... Actually, this is fine. I divide by the amount of cubes, and I should get the good coordinates. So I should actually have something here. Do I? Chunk chords, never mind. Oh wait, chords in cubes. Well, let's just have a function here. That's going to be cube coordinates to chunk coordinates. Cube chords to chunk chords. And we're gonna return, and this is gonna take the coordinates of the cube, like yeah, it's a cube, and we divide by the default chunk size. By default. Okay, it's good, it's neat. So now I can do observer chords. I can do this. So I get the chunk coordinate of the player, and I mean, observer chunk chords. Let's actually just have something there. Like this. Cube space. I mean, technically, I should be able to do it directly from the observer. So gets. Gets chunk chords. Yeah, but it has to be the collision sim though. Collision sim cards. Yeah, collision sim cards. Get collision sim chunk cards, something like that. Get collision sim chunk cards. And it's basically this divided by this. Right. Kind of. I guess I... Wait. It's going to be a... Yeah, it's going to floor that. Actually, wait. It's going to truncate, right? Can I just floor? Because... if it's less than 0, if it's like -1, I want to floor it to something, I guess. Wait, I'm not sure how this is converting things. I guess I want to floor, then divide, and then floor again. Wait. So let's say this is -1. -1 divided by 2 is still -1. -3 divided by 2. Wait. Am I stupid? Why am I getting confused by something like this? Okay, so let's say 2 divided by 5 is 0. Right. It can still be 0. It's like -1 divided by... this is going to be 0 too. Yeah, that's a problem with the negative numbers, with the negative coordinates. Wait, how did you do it well again? I think you just need it to be a vector free. You divide and then you floor, right? Because if you divide by integrals right away, it's just not going to work. So wait, but I don't really want it to be about floss though. I don't want to use floating points because of precision and stuff. Oh, it's actually collision sim. It's actually already a vector free. Yeah, never mind. Should be good. So I do this, and then I floor. And like -2 divided by 5 is minus something. So then I floor. So it should be -1. And then, yeah, it's getting converted into an int, and it should be good. So this is get sim collision sim chunk cards. Good. Then I do cube cards to chunk cards. Nope. It's just observer chunk cards. So I get the chunks around. I shape. I need the shape. So do I have the shape? Yeah, this is it. Well, first I have to check if I have the instance, right? So for that I can use a hash map. Should I put it in the parent though? I think this is a good idea. So here, for example, I can have the collider instance. I can generate it, but I can also get it, like find collider instance. So find collider instance based, well, from the chunk coordinates, right? Yeah. Yeah, that should be good. And this is basically just going to return something that's from a hash map. So we're going to have another hash map here, like in the simulation group actually. Wait. Yeah, my bad. It's from the... It's not from here. It should be from the simulation group. So here, I have find collider instance, and I have a hash map. So it's like core templates hash map. What is what is that? Array. Oh! By the index by using get by index. Oh, this is good. Array hash map. Still not erase the elements because ID can break. Okay. When an element erases, its place is taken by the element from the end. Right. RB map if you need to iterate over sorted elements. So red, black, tree map, I guess. Hash map if you need to keep an iterator or a const pointer to key and you intend to add / remove elements in the meantime. Wait. And you need to preserve the insertion order when using arrays. Insertion order, okay. It is recommended to use hash map if key value size is very large. Key value size. Right. Okay. Should be fine. Yeah, that makes sense. Maybe. Yeah, because of copies, right? So its place is taken by the element from the end. So yeah, there's basically this kind of copy. Wait. What's like a dynamic array, adding elements to the end of the array. And allows you to access array elements by their index by using get by index method. So you have the map. You do something. Wait, what? Get index, get by index. Oh, okay, got it. Don't erase the elements because ID can break. Can I erase them? When an element erases, its place is taken by the element from the end. So it's swapping, it's just swapping. I mean, this is fine. So let's say I erase this one. That means this one is getting here. This is not a big deal. I don't mind that. So we have the elements, we have metadata. Capacity hash. I mean, this should be fine, really. I think I can use, well, and you intend to add / remove elements in the meantime. I am not going to do that. And you need to preserve. I mean, this is a pretty strong indication. Well, recommendation. But I think I'm gonna use it. Must be a power of 2. Oh, okay. So AS map. And I'm going to have a AS map. And this is going to be from the position. Is it? Let me think. That means I'm gonna have to move the player too, though. But I mean, I guess that's fine, because I can optimize things this way. Can I? I mean, technically. Yeah, it should be good. Yeah, so this is a pretty specific implementation, but that's fine. I just hope it's going to work well, because I'm working so much just for this. Yeah, received number not allowed. Yeah. So I have the instance. I want to find the instance from the coordinates. So we have the chunk coordinates and we have the instance. So that should be pretty. This is not a big, like the classes are not big, so it should be like pretty optimized still, let's say. And this is basically chunk called to instance. So collision chunk called maybe. Like maybe I need a class for referentials and stuff, because this is becoming a problem, really. Like maybe in utils actually, I can maybe have this, like utilities, helpers. What was it? Oh, voxel. Helpers. So let's say I have this. Wait, what? Let's change this. Okay. And yeah, we're basically going to... It's not a template. What do you mean? Yeah, that's fine. Let's just have here. I'm going to move it at one point. Actually, let's do it right now. So utils. We're just going to have a .h that's going to be coordinates. Coordinates referentials. .h. And I don't have to rebuild anything. It's gonna go there. referentials that, well, h, I can remove a lot of things, and we're going to have something like collision theme cards, like cards location, like vector 3. So I'm just going to include this though. Car math vector 3. Car math vector 3. So we have this. We are going to have collision theme chunk cards. So this is a vector 3 I guess. That's like infinitely big, potentially. Infinitely big. Well, not limited to the space, maybe? Well, I mean, it kind of depends actually. Like cube, chunk cards. Collision chunk cards to instance. So something like this, and I can include modules, voxels, utils, referentials. So I have this. Okay, pretty good. Then I should have the same for the player actually. Or do I? Potential. Collision sim location, like position, I guess. I'm thinking in Unreal, right? Because I've learned through Unreal Engine. In Unreal, it's like location everywhere. But in Godot, it's position, so I guess I'm going to use position. And then we also have the cube coordinates. So we have cube cards and cube chunk cards. So this should be good. And the good thing with this is that we can increase the precision if we want a bigger precision. Collision, yeah. Okay. So let me just quickly go in every collision class to see if I can replace. I can't. Cube chunk shape. Shape, okay, this is fine. Then I have what do I have? I mean, this is fine. Okay, this one is going to, never mind. Where is the space? Wait, what? I guess there's really nothing here. So as instance, wait, I actually don't have anything. Wait, this is crazy. I guess there's just a raycast after that, but I'm not checking this one, I'm not using this one. So it's actually just a C++ thing, okay. Find collider instance. Oh yeah, from this. Whoa. So from this, and I'm just going to return this. Oh, like this. Whoa. It's getting a bit big, isn't it? This.get. And I get the coordinates. There. Like this. What happens if it, yes, returns null if it doesn't exist, right? Actually, hashmap key not found. Oh no. Crash. Oh no. has erase, replace. What does it have, like a find? Oh, it has a find. So what is that? It's an iterator. Okay. So I guess I can have the iterator. Is there like a try get? But there isn't. Wait, what? A suitable conversion from iterator to chunk collider. Yeah, I know. This is fine. If this is equal to end, then I'm going to return null. And else I'm going to return the value of the iterator. Or maybe I guess I can't do that. A suitable conversion from map key value. Oh, so it's a map to the instance. So this is value that I want to return. And I don't really get this though. This should be good. Let's try to compile. And then we have the whole C++ to think about. So when I generate... Yeah, okay. Problems. Ref. Oh, so I did have a problem with ref here. Why am I using this though? Oh yeah, it's a template. Wait. Yeah, I guess it's because I have nothing in the C++. So let's just check where this is from. Core object ref counted. Core object ref counted. Here we go. We can try again maybe, or maybe set collider is not a member of chunk. Yes, it's set shape. Wait, what? This? Yeah, should be good. Cast 2 should be good, but because now we have an include. Well, another one. Well, maybe it's not gonna be good, but I mean, we're just gonna see how it goes, right? Undeclared identifier. So this is cube chunk. Probably. Cube space. Wait, I actually don't have... Well, actually, no, this is cube chunk. Wait. Yeah, okay, never mind. I have to find it. That was the whole point. Find chunk index. Find the chunk, I guess, right now. And if it is null, so get, yeah, is get, yeah, that's what I thought. Gets pointer. Oh, I guess it's get pointer that I want. Yeah, I want to get pointer. Yeah, okay, I want to get pointer. Well, actually, this is a bit complicated now. Wait. Find chunk index. Yeah, so it's like, it's checked. Okay, this one is checked. And find. I guess it's a get chunk index. Where am I using this? Here. I need to get the instance first. Yeah, because this is not good anyways. This is not good anyways. This is from a vector I. Okay, I actually... Yeah, okay, actually, this is not in collisions that I have to set the types. This is in here. So, actually it's... well, modules, voxel, utils, referentials. And this is going to be... collision sim... Nope. This is going to be chunk cards. Chunk cards. Well, cube chunk cards, maybe. Yep. Cube chunk cards. Cube chunk. Well, cube cards. It's the same. And I should not have a vector free here. So cube chunk cards. Default chunk size. So something like this. Well. Cube cards. Cube. Position. I mean, this is an amount. Chunk size. So this is in cubes. Using, well, I guess we have chunk size. Well, this one may be a bit tricky. NB cubes. Yeah, NB cubes, what's the difference between... Oh, that's the whole space. Chunk. I mean, I guess this is fine. I don't need more than that. But then we have chunk cards. Cube chunk cards. And in NB cubes, those ones are fine, but then we have this. We have to be careful. Cube cards, so cube cards to chunk cards. Here we go. Here we go. Should be pretty much the same, but yeah. Cards in cubes. Cube chunk cards. Then you have... Well, we have cube cards, I guess. Cube chunk cards. Current chunk size. This is fine. Set chunk cards. So like this, we have the coordinates. The rest is fine. This is not fine. Is it? Oh no, it is. It probably is. Is it? Yeah. Gets block index. What is that though? I'm glad I'm adding types because I don't know what this is. Local cube cards maybe is in chunk. So this is cube cards probably. set local cube cards. So yeah, I'm glad I made this. Local cube cards. And this is relative cards of a cube relative to the chunk. Cards of the chunk relative to the space. Well, in the space. And cube cards is, I guess it's like the global coordinates. So like, well, cards of the chunk relative to the space, really. And if I want to remove one, I know where to do it. So this is fine. I mean, I guess I can always even like replace it by a struct that's like a bit bigger. So it should be like even better. Well, even it should be fine. Where is it? I don't know. So we have get squared distance. What? Set local block. The cube local cards. Set block size. 8. Wait, what? Get block index. What? I'm not sure about this. So this is the local position. Oh, and this is local too. Is in chunk local. Yep. Cards. Oh, this one is wrong. Wait, no, wait. NB blocks. No, this is fine actually. This is good. Why is it a problem? Error. No, it shouldn't be an error. Oh, okay, it should be an error. Never mind. Modules, voxel, utils, referentials. So yeah, this should be good now. Should it? Yeah, I just have the integer that's kind of wrong. That is gonna be this, you know, just to be sure that we have enough, that this is big enough, because get local block like int 8, that's not a lot, especially in 3D. Sets block size, so this is just the size block index. So this is in local coordinates. This is important. I mean, I could have a reference really. Wait, that's what I had before. Wait. I just realized, but it should be a reference. Yeah, why was it not a reference? Here we go. Oh, I guess it was because I wasn't sure about the bindings, because it was crashing at the time. I think that's the reason why. The amount of blocks. Should be good. Should be good. I'm not sure about this though. Is it? It's not even there. It's quite distance. I guess this is fine. I'm not even... Wait, I am using... No, I'm not. This is quick hell. Yeah, let's just remove it for now. Wait, blocks. Wait a second. Oh. Cube chunk. Wait, I've been bamboozled. Get local block. Never mind, this is... Okay, this is actually block type. Yeah, so like block... Well, cube. Equal... this. Then I set like this. Yeah, I just need to get the type there from the class. And remove this. I should have a lot of things good. I don't remember what I was doing though. I was doing the find collider instance. And I was checking this. And if this is equal to end, then I return null. Right, I'm creating an iterator though. Can I just get pointer? So this is going to be basically... Oh, right. Okay, this is fine actually, I can just return this. Okay, this is good. I like it. Yeah, this is good, I like it. So I don't need the if, right? Finds collider instance. I'm going to use this. Well, to search for it. Actually, maybe not. Where was it from? There? No, it was from cube chunk space collider. Find the chunk. Yeah. So we have the sim group, and we want to find collider instance from the coordinates. So collision sim cube chunk coordinates. Let's go there. Let's have chunk coordinates. So here plus this. I mean, I guess I can just have chunk cards. That is 0, 0, 0. Is it? No, it's not. Observer chunk cards. Yeah, what is that? It's cube chunk space. Oh no, it's... Wait. Oh no. Cube chunk cards. Okay. Then we have this, that is collision sim cards. So collision sim cards, maybe. Cards. Yeah. Should be fine. Cube chunk coordinates. Cube chunk coordinates. Wait. Cards. So this is a vec 3, right? Never mind. Wait, what? Cube cards. Wait. Wait a second. Yeah, this is fine. This one is fine. And this one is about the simulation, so sim chunk cards. Collision, sim, chunk, cards. Something like that. So I can take this. I can go here. I can get the cards. I get this, and now I can add, and it's not a problem. I actually want to do instead of okay, I mean I guess the Y yeah, Y should be the latest probably. So Y equals this or like delta. Let me think. Delta chunk cards, maybe. Then we have Z, maybe. And then maybe we have X. So this. X and X. And finally we have just the plus. Observer chunk cards plus the delta chunk cards. And now I can try to find this collision sim cube chunk cards, so same type, should be good. And this is in line, great. Now I can get this, so I have the instance. Like, wait, what? This. Boom. What? What's happening? Wait, what was that from? From the simulation group, so sim group. I get it. I get this. And do we have an instance already there? If we do, well, if we don't, I guess, we can create it. So everything is gonna be kind of in. So if we don't, we can generate collider instance. So yeah, it's the instance. I guess it's chunk collider instance, but this is fine. Same group. Do we have the shape? We don't have the shape. So we need the shape. But to find the shape, we need to find the chunk. And right now, I have to convert from the simulation coordinates to the not simulation coordinates. So maybe I'm gonna chunk space collider. Maybe this is gonna be like a static function. That's gonna be chunk collider, no, collision sim cube chunk cards to cube chunk cards. Yep. This is a big function name, but it should be fine. I'm just gonna have it like here, the static function is gonna return, well, I mean, we already know, right? Like this, we are gonna have this in. We're gonna return. And this is basically gonna be, so this can differ. This can be a bit tricky, really. But the point is we want a positive modulo. We want a positive modulo. Oh, we want a modulo though. That means we need chunk space. Okay, maybe it's not going to be static. So let's say we have this space. So this requires us checked cast. Maybe with V. I guess I don't have it here though. It's fine. Modules, voxel, is it? Yeah. Details, voxel helpers. So this is cube chunk space. Cube chunk, well, cube space, well, cube space, I guess. And this is gonna be from get space. So we get the space, and we ensure this is a cube chunk space. We return maybe 0 by default. And now that we have this, we have the coordinates, and we divide by, well, we don't divide actually. No, this is a modulo. So we have chunk, oh wait, this is chunk, never mind. NV cubes, so this is the amount of cubes in total. Oh right, the amount of cubes, that's the amount of chunks. Get NV chunks, maybe? I mean, it depends if like it's finite or not. Well, but I mean, I guess it's considering, well, yeah. It's considering that this is, maybe I can just put the amount of cubes to the max. That would make sense. Like infinite is just, you have the maximum amount here. So if we do that, I guess that makes sense. If we have what is it? Get NB chunks. Which is the amount of cubes divided by the default chunk size. Wait, this is, wait, amount in each direction. So NV chunks. And then I can test if this times this, well, if this times this equal the amount of cubes, then I guess I can just return. Oh, maybe there's like a +1. Wait a second. Why is it? Yeah, I guess I can just do a +1 somewhere in the division, like there. cubes. So let's say I have 50 cubes. Then when I divide, it's like one chunk. Oh, it's like plus. Okay, I get it. Like NB cubes plus this minus vector 3i 1 1 1. And the reason is because if this is equal, then this is gonna be the same with the division. But if there is one more cube, then it's going to add 1 because of the division. Because of this. So we have the amount of chunks. What did I want to do with this? I forgot. Yeah, here. I want to... Wait, divide? No, I want to modulo this. I want to modulo... Do I? Wait. No, that's not what I want. Wait, this is actually a bit tricky. This is a trick. I shouldn't really use this though. But, wait, what do I want to convert? Equation sim cube chunk chords. So chunk coordinates to cube chunk chords. Well, actually, if this is chunk chords, that should be fine. Right? And it has to be positive though. It has to be positive. What was it again? I think it was something like this, and you can modulo again. Positive modulo. Wait, does it actually have a function already? Maybe, like if I go there, like modulo. No, there's probably like an override. Proto vector 3i positive modulo. Global scope dot posmod. Oh, posmod. Wait, C++. To positive modulo. Yeah, so this is actually what I was. No, never mind. Yeah, I was gonna do that, but component wise. Yeah. Okay. So yeah, kind of bad, but let's modulo. Then we can. Okay, this is fine. Is it? Am I going to use it again? I don't know. Yeah, I really want this template. Type name A, type name B. You're gonna have post modulo A, B. Well, actually, it's the same type, right? B. Then we return A modulo B plus B modulo B. Just gonna do this. Int assumed. Oh, right. And return T. So now I can just call this function. Like this. Maybe. No instance. Vector 3i and collision sim cube chunk. Wait. So I have. Wait, what? Cube chunk cards. Wait. So this is this, and the amount of cubes. This is the amount of chunks. No, this is fine. This should be fine. I guess this is a different type technically, though. But this is fine. I'm just gonna specify that this is vector 3i. Oh, that like references, right? Cons collision and vector 3i. Yeah. This is fine. Is it good now? What do you mean? The instance of function template matches the argument list. Arguments are vector 3i, vector 3i. What about... Well, it's supposed to work. Oh, right, never mind. I don't need two of them. So now I can remove this. And yeah, it still works. Good. So this is good. I can go here. So I try to find the chunk. Am I going to find it actually? I probably want to do the same and return like a pointer towards a pointer. If I don't find it, I should load it for sure. Gets like find or load chunk, maybe. Oh yeah, this is a problem. What about the generation? I mean, it depends if we really need it or not. So wait, I have chunk. Yeah. I mean, if I don't find it, yeah, let's return something like this. And chunks, it's like the parent, right? It's a vector. Wait, what? Chunk space. Oh. Oh, okay. Yeah. So the hash map, right? I have the get. it should be gets pointer. That way I have a pointer towards this. And well, I have the index, and if this is null, well, return this equal null. If yes, this is null. If not, this is the chunk. With this. So find the chunk. If it's null, I have to load it. Maybe. Like load, like chunk. Try load chunk, I guess. I still have to implement it, I know. And this is gonna be a pain, but yeah, I tried to load it. Maybe async. It depends if it's urgent or not. And maybe I want to have a boolean around for that. Yeah, I'm spending so much time on collisions, that's crazy. Argument of type chunk is incompatible with the shape. Yeah. So this is basically going to be to do async. And basically I get the chunk there, and if I mean, yeah, now. I guess this is gonna be to do imp. Yeah. To do couldn't load chunk. Load async, maybe. Okay. And then let's say we have the chunk. I mean, okay, yeah, let's just return here. And we just have error message, failed message. Here we go. Here we go. So now I should get the shape. So now that I have the chunk, I can get the shape from this, get shape. And if this is null, I have to instantiate it. Oh my god, so many checks. Generate collider instance. Wait. Find collider instance. So if this is not valid. Okay, never mind. Okay, yeah, I want to create this one first. Wait. Okay. So if I have the chunk, I can generate No, wait, okay. Yeah, I need the shape. I need the shape. Yeah, okay, I need the shape. So I get the shape. And it depends if it exists or not, right? So if this is... let's actually assign it to a variable. Like this. Shape. If this is null. Like this. If this is not valid, then I try to create it somewhere. I don't know where. Create chunk. Yeah, there's the spawn chunk shape though also. Let me spawn chunk shape. Yeah, it's there. In the space collider. So it's... wait. Let me look at this. Why am I even using the function? Here. So I can get the space, I can generate it, and then I can create the instance and stuff. So let's go here. If this is not valid, then I'm going to chunk shape. And I guess I'm going to cast. This should be... okay, so this should be checked cast. That should always be the correct one. The shape should always be a chunk shape in this case. I mean, actually, I don't know, because what if it's like in multiple... oh no, what if it's in multiple spaces at once? I'm not sure about this. But I mean, in this case, I will have to modify this a bit more, because I have only one reference to a single space here. Wait, that's the chunk though. Oh, never mind, it's for a chunk. So yeah, okay, this is good. This is fine. This should be good. This should be good. Everything should be good. Okay. So in this case, I can remove this. I have the shape. If it is not null. Oh, wait a second. Oh, right, it can be null. It can be null. I guess I'm going to do something like this. I don't know. Yeah, maybe this is fine. I'm just gonna have this here. And... and what? Space. So this is get space. Spawn chunk, it doesn't contain. Oh, is it because it's wait. Chunk space. Can I just do this? Yep, I can. Spawn chunk shape. From the chunk, we get the shape. And then we generate, I guess. So to do async, maybe. And then we want to set the shape back. So here we have set shape to the shape that we currently created, that we just created. I guess we can do that right away, and to do we can handle it asynchronously. So it depends on this probably. In this case we can have like a is close. Maybe. Oh, so I guess it's a bit different. Delta chords. -1, -1. Can I just do distance, well, length squared? And this is going to be 3. Oh, MG, got a simple. Yeah, Robert! Hey, how are you? How are you? Nice to meet you. Well, nice to see you. It's like militancy is like very similar in French and other languages, so sorry about that. Yeah, good. Great. Yeah, C++ because, oh, yeah, you're not aware of what I'm doing, right? Well, I mean, you can see it from the name of the stream, I guess. I have to show you something. I was trying to handle collisions though, but I can see that a bit later. Well, I mean, I've been seeing that for like days. C++ because GDScript sucks. No. Well, Speedwise, yeah. Well, and not even that. It's also for like I would say the architecture and there's a lot of reasons. And like for ease of maintenance and stuff. Because, well, basically right now I'm making some kind of voxel, I'm gonna say voxel engine, right? Like I'm going to add a voxel module to the engine. This is the engine. And you have C++ bindings too, but I'm making this distinction that bindings are for gameplay and that engine modules are for new engine features, right? And to me it's like an engine feature kind of. A voxel engine it is. Yeah, kind of. So that's why I'm here. That's why I'm doing that in the source code of Godot in a module. It's like an independent module. So it's like there's not a strict dependency to this, but I can use it if I want. And this is pretty great so far. This is pretty good. I have to tell you about all the complexities of what I'm doing though. Yeah, I do have a lot of problems. So this unknown override. Okay, so I have the helpers and I'm gonna include referentials. So yeah, I basically have, okay, I'm gonna show you. I basically have a class referential because of how many referentials I have. I have way too many referentials. And you're going to understand why very soon. I'm gonna drink a little. Why so a thing like that? A thing like that? What do you mean? Oh no, problems. Oh, maybe I need this. This is a good idea. Okay. People just add includes my stuff. And add this as no, this is not what I'm doing. This is not what I'm doing. No. I'm trying to separate it. I'm trying to split it. Well, maybe I have some kind of stuff like that, but I'm talking like about a referential header specifically. Undeclared. Wait a second. Referentials. Yeah, let's have this in the C++, I guess. There. Yeah, sorry about all of those errors. Ew. But basically right now I split my code, my voxel code with like utilities. I guess that's like one class I have, well, one file I have to remove and two other things. I have the core, so that includes like the chunks, for example. I have the rendering part, so when I'm rendering a chunk, and I have the collision parts, so like when I'm colliding the chunk. Yeah, I know that wasn't very obvious, right? But yeah. Here we go, we're gonna return that directly. And now it should be good. Let me just in the meantime check back what it's like 6 AM, don't mind this too much. I need this. I need to go here. Oh wait, there's some problems. Too many arguments. Oh, right. Yeah, I don't have to check. Returning address. I mean, I guess it's linking, right? So that should be good. That should be good. Then we have address of local variable. This is fine. Bah. Do I... So yes, the shape. Do I have the shape? If I don't, I generate. Okay, let's actually do things now. You're missing thousands of viewers. Wait, the Summer Game Awards 2026 stream from you. Yeah! Yeah, I missed it. I missed it. I know. Wait, when was it? It was like 2 weeks ago. The show will start at... Wait, what? Wait, is that it? Wait. Just wait. Wait, when is it? Wait. I'm gonna change it right now. Oh, so wait, what about the English? Is that it? Don't know when. 2 PT 5 9. This is not my time. Wait, 9 GMT to 9 PM GMT to my time. Oh, it's like in... Okay, it's like in 15 minutes, I guess. Japan is 9 hours ahead. In 15 minutes, huh? I mean, thank you a lot. You're saving me. Because something happened like very recently with like some game showcase. But I just don't know. I'm just not used to watching them. I don't know anything at all. I actually wanna maybe stop the stream to... It began 2 hours ago. Wait, what? It began? What do you mean? It's not there. Wait, what? Mandarin. Wait, what is all of this? No, it didn't. GPT said it to me. Yeah, but GPT, right? It's like saying it here. Summer Game Fest. How did voxels get so small? I might actually stop my YouTube stream really soon to have this. I'm just gonna keep this in the background. I hope the music is fine. But yeah, I'm gonna show you what I'm doing. Wait, no. So I'm gonna remove the colliders for now. And I'm gonna go there and remove this function. The secret function. Okay. Okay. So basically what I'm doing is... What the fuck is that? Wait! That's not how it's supposed to be. What the fuck is that? What the... Wait, this is actually crazy. What is that? It's not cubed Minecraft. It is supposed to be. Wait, can I... No, I can't destroy. Wait, what? I broke something. It's circle Minecraft. Wait a second. No, I forgot to commit. Did I? Okay, I didn't change anything here. What about this? Okay. Oh, this is because of the chunk coordinates, I think. Oh, because I changed how it worked. Oh no, I'm sorry. I mean, maybe I can just stash what I have to show you. I stopped coding some time ago and started knitting, by the way. Knitting, okay. So I set the shape. Because, yeah, it doesn't have to do with, like, the colliders. I only changed the colliders, right? Wait a second. So, collisions, I don't care about this. Let's go with core. So, get shape. Oh, right. Maybe I have something here. No, I don't. Let me... Yeah, this is kind of important. It broke entirely. Senpai? You want me to knit you a sweater, senpai? I don't know. Like index. Local cube. All of this should be fine. Chunk cars. Okay, blocks. Should be good. Set chunk coords. So yeah, the chunk coordinates. I think I know why it's doing that, but yeah. Chords in cubes. So you know what? I can actually see ways doing that very easily. Okay. This is interesting. Right? So I have a chunk. Yeah. It's borrowing Minecraft now. Yeah, sorry about that. So it's when I'm generating. Like there. Generate all chunks. Oh, it broke here. So sets chunk cost. Yeah, okay, this is what I was. Oh, because I should have like the position probably somewhere. Chunk space. seconds. Summer game. What Twitch category should I put? I mean, I guess game coding, because I'm gonna watch the Summer Game Fest, right? So I'm not sure about that. Are you sure? Oh, just chatting. Oh, right. Good idea. Good idea. Okay, I changed. Yeah. Nice. I'm gonna... So yeah, those... Oh, so it's about the visuals. Oh, right. Okay, I get it. Maybe. Wait a second. It's not about here. It's about... Chunk, this is good. Chunks... Cube chunk space. Or the torus. Never mind. There's something here. There is something here. Generate all chunks. So I have the coordinates. Do you have an idea how they made Euphoria engine for GTA 4? And how to replicate something like that? I don't know what this is. Character, I mean. What? Euphoria engine GTA 4 character. I mean, yeah. Uniquely to every impact. Instead of stimulates the character's muscles. So basically, a nervous system. So basically, if you simulate that, you want probably inverse kinematics. Okay. You played Rockstar Games? I haven't actually. But yeah, it's called inverse kinematics. And I actually made some... well, I made some soft body. And, you know, this is like the kind of animation that means you can put your foot on like the specific place on the stairs. Oh, what do you have? Yeah, but yeah, this is it. It's probably a bit of an exaggeration to say they replicated every muscle and that kind of stuff, right? Because we have like a lot of muscles. There's like a nice GDC about it, about inverse kinematics if you want. GDC. Is it GDC? Maybe it's not GDC. Procedural animations. That's another name, but that's the same thing. I can't find it. Maybe it's not GDC. I mean, I guess there's that, right? You have this video that is great to learn about it. This one is like good for soft body. This is the one I followed actually. Yeah, this one. Well, I mean, you have a lot of nice ones, right? Spiders, legs. Oop. And yeah, Rain World is, you know, it's a lot about procedural animations too. Like this, right? can I, like here, for example, you have the different enemies, right? This is the same. It's like fusing for the player, it's like mixing with some pre-made animations, I think, but yeah. Anyways. Let me maybe stop YouTube right now. But